To develop a vertical platformer, we're going to create a physics simulation from scratch using concepts like gravity and collision detection. After that, we'll import collision blocks from a map editor called Tiled, and use them to give our map boundaries and platforms that we can jump on. We'll add sprite sheets and animation for when our player runs, jumps, and falls, then implement a game camera that moves in all directions based on where our player is traveling. Finally, we'll upload our game to a live URL using an affordable hosting provider called Hostinger, so that anyone on the web can play our game. There are some similar concepts here from the multi-room platformer tutorial, so if you feel comfortable, skip ahead as needed. Otherwise, let's get started. So the first thing we're going to do is set up our project so that we have a canvas in which we can render our game out onto. How would I go about doing that? Well, the first thing I would do is open up a Finder window. Once I have this open, I want to create a new directory, and this is just within a folder in which I create all my games in. This is web. I want to create a new directory called vertical-platformer, because that is going to be the name of this game. So once I have that created, I want to open it up in a text editor of my choice. I like using Sublime Text, so I'll open that up now. And once you have this opened up, you're going to want to create an index.html file to house our actual canvas element. So by default, Sublime Text opens up a file. I'm going to save this with Command S. And then inside of my web directory, where I have my vertical platformer, I want to call this index.html. Simple enough. So now all we need to do is add in a canvas element, and I'll do so like this. And now I can open this up within the browser to view what it is I'm actually developing. How do I open this up within the browser? Well, I'll go back to Finder and then double click index.html. And now you can see this is what our project looks like. It doesn't look like anything's on there, but if I inspect our elements, you can see within this elements tab, we do indeed have a canvas element. This is the one that we added on within our project over here. So great, we're on the right track. What would I do next? Well, I want to make sure that I can actually see our canvas element contrasting with the background. So back in index.html, I'm going to add in some style tags so I can begin writing some CSS. And I'll add in a body element. I'm targeting the body element, and I can specify what type of CSS do I want to apply to this body element. Well, I want to apply the background property and set this equal to black. So if I save this and refresh, now our entire screen is black instead of white. That is a good start. This is basically a dark mode. It's a little easier on the eyes. I always prefer it, but I always want to make sure that our canvas is showing so I can see what the hell is going on. So to make sure that our canvas is showing, I can add some script tags down below. It's going to look a little like this. And now I can begin referencing our canvas element directly within JavaScript land, as I call it. So anything within the script tags is JavaScript land. Now, I want to grab this canvas element inside of here. How do I do that? Well, I want to create a const called canvas. And inside of this canvas const, I'm going to grab this element with document.query selector with a capital S. And now I can specify what element do I want to grab. Well, simply the one called canvas. It's going to be the very first step. And now I can go ahead and grab what's known as our canvas context. I'm going to call this C, and this is pretty much the only time in which I'll use a really short variable name like C, because I know I'm going to be using this a lot throughout this game. And me personally, since I'm only working on it, I know C is going to stand for context. So in this case, it's totally okay to use a short variable name like this. Now my C context is going to be equal to our canvas.get context method. And get context takes an argument. It's going to be a string which specifies what context do we want to grab, basically what type of API do we want to grab, a 3D one or a 2D one. I want to grab the 2D API. I'm going to store that inside of C, and now I can begin drawing on top of our canvas element. Now eventually, as we begin coding more and more of our game, our JavaScript, everything within these script tags, is going to get larger and larger and larger. And as it gets larger, well, it's going to become a little more maintainable if we were to put this inside of its own separate file. So in this case, we will preemptively put this in its own file to make sure that later on when our file gets bigger, it's easier to manage. So yes, these script tags will work, but I'm going to grab these two lines in which I just created, delete the script tags, and then go to File, New File, and paste in those two lines in which I just created. So I want to hit Command S here and save this file as not untitled.html, but rather index.js, our main JavaScript file. And I can save this within the root directory of vertical platformer. Make sure that I use JS right here. And there we go. Now we have our own separate index.js file, but one issue is if we were to run index.html, well, we wouldn't be pulling in index.js by default. We need to specify manually that we want to run this code. And we can do that by pulling in some script tags again, but in this case, we're going to use the source attribute to reference this file right here. And I could grab that simply by typing index.js. We want to make sure that our code is running within index.js now. So make sure that you save index.html, and inside of index.js, I'm going to console log out, let's just say C, our canvas context. So I want to save that, refresh. We don't see anything because we're just console logging out some text. So you want to make sure that you right click, hit inspect element, and then go over to your console tab. And you can see we are logging out that canvas context. This pretty much contains everything we're going to be using to actually draw elements on the canvas. So we know everything is pulled in correctly, and we know we have our canvas context. Let's start using it. To draw a rectangle on top of our canvas, we're going to use c.fillRect, which takes 4 arguments. The first one is going to be an x coordinate. Let's just say our x is going to be 10 pixels from the left of the canvas. Our y coordinate is going to be 10 pixels from the top. And then the third argument is going to be the width of this rectangle we're about to draw. I'll say it's 50 pixels wide, and then the fourth one is going to be our height, so in this case it'll be 50 pixels tall. If I were to save and refresh, we don't see anything because by default Canvas is going to draw with a black rectangle. If we want to specify what color this rectangle should be, right before we call c.fillRect, we want to call c.fillStyle like so, and set it equal to the color in which we want to use. In this case I just want to use white so it contrasts with the black background. Hit save and refresh, and there is our white rectangle on top of our canvas. But if I were to inspect this by right-clicking and hovering over our canvas tag right here, you're going to see our canvas is only 300 by 150 pixels wide and tall. So I want to make sure that this extends a bit further because this is a really small area for our game to run in. I at least want it to be 1024 by 576. That is a 16 by 9 aspect ratio. It's going to fit on most small desktop screen sizes. So I think that is going to be a good size for our canvas element. How do we resize our canvas element to that size? Well, back within index.js, right beneath where we call c is equal to getContext, I'm going to reference our canvas object which we pulled in at the very top. And I want to specify that our canvas width is equal to 1024. It's as easy as that. We want to do the same thing for our height. I'm going to set our height equal to canvas.height. Set that equal to 576. And now we have a 16 by 9 aspect ratio. If I save and refresh, still can't see anything just yet, but if I hover over canvas, you can see that it's definitely taking up the full 1024 by 576 pixels we specified. Now let's just make sure that this rectangle right here takes up our full canvas width and height to really get that canvas contrast in which we want to make sure that we can see where it is we're rendering out our game. So right here where we're calling c.fillRect, yes we have an x, yes we have a y, but I want these to start from the top left hand corner of our canvas. So I want our x to be 0, I want our y to be 0, and then I want these to extend the full width and height of the canvas. So for this third argument, this is going to be our canvas width. I want to specify that it should actually be equal to the width we set up above by referencing canvas.width. Same thing for our height over here. I'm going to replace that with canvas.height. So now we're referencing these variables right here. We save and refresh. And when we draw this new white rectangle, you can see now it takes up the full width and height of the canvas in which we want to draw on. So that's pretty much all we need to do for project setup. Let's head back over to our to-do list and check off project setup. Now it's very likely as you develop your game, you're going to want to host this on a live URL, something like chriscourses.com, chriscourses.games, or whatever it might be for your end. And if that is the case, well, we need to make sure that we set this up so we can begin uploading our game in increments. We're going to do this in the beginning and at the very end, but it's very important that I show you how to do this. So if you want to stop halfway through this and upload just that game to the web, you can. So here's how we're going to do it. We're going to go over to our browser window and open up a new tab, and we're going to visit hostinger.com/chriscourses. And once we're here, we're going to want to sign up for some hosting. So right here, they have a Black Friday deal going on at the moment. But if you scroll on down, you can go ahead and get some premium web hosting for a very cheap price. You're going to want to add this to cart. Premium shared hosting is what I have currently. Let's add that to the cart and see what we need to do next. And here on the cart page, you can see all the pricing plans associated with Hostinger. So if you go ahead and sign up for 4 to 8 months from the get-go, Yes, this is going to be $100 something, but you're only going to have to pay $249 a month. That is extremely low for any hosting or domain. And you can see that down below, right here, the total price would actually be $119. Let's say that is a little too much for you. You might want to go down to just the yearly plan, which is $299 a month, and you get a free domain for the first year. This is probably the best value for the shortest amount of time, in my opinion. Scroll on down, you're only going to pay $35 for the full year, and you get a free domain for the first year as well. In addition, there's going to be a coupon code associated with the video, so we can click this button right here and enter that code. It is going to be Chris Courses, simple enough. Hit apply, and we're going to have an additional 7% taken off the total price. The coupon has been applied and we are good to go. So this is what I have currently. If you'd like to just test this out for a month, you can do this over here, $12.49, but at the same time, you're not going to get that free domain. So make your selection and go through the payment process. Obviously, I'm not going to go through this myself just because I don't want to show this to everyone on YouTube, but I do already have premium hosting available to me along with a free domain. And once you have your web hosting purchase, you should be greeted with a screen that looks like this. So we're going to start with our domain registration. You can see the domain I chose is Chris Courses XYZ. This is my free domain that I have. I'm going to go over to setup and go through that process real quick. And all I need to do here is choose a country. So I'll say United States, and then enter my contact details. So I'm not going to show this on screen, but all you need to do is put in these details there and then proceed to the next step. So I clicked next, now you can see that is being registered, and now my contact information is under review, so we're pretty much good to go here. We can hit continue, and proceed on to the next step. So this is my domain. I do want to go back to my hosting though. So I'm going to click the home right here, and we can see down here our domain is in a different section now. I want to focus on setting up our premium shared hosting. So I'm going to go over to setup, and then just go through this process. So I hit start now. Answer this question, who are you creating the website for? I'm creating it for myself. Who is creating a website? And you really don't need to go through this step. You can just hit skip. Let's do that. Make it quick. Migrate or create a new website. Well, we want to migrate our current website, the one we're currently developing that we just did project setup for. So I'm going to hit select right here for migrate my website. And then do we want to upload our website or transfer our website? Well, in this case, I want to upload the index.html file and the JavaScript file directly to Hostinger. So right here, I'm going to click upload website. And then here we need to provide a zip, tar, or gz archive of all of our website files and basically just upload it right here. So how do we go about doing this really quickly? Well, over in our Finder, we want to find our vertical platformer, right click it, and then we want to compress it. So I'll click this compress option right here, and that's going to transform it into a zip file. Once I have that zip file available to us, I can go back to Hostinger, choose a file, and I want to make sure that I select that zip file. So right here is going to be verticalplatformer.zip, double click it, and now we can hit import and it's going to upload our game directly to our new hosting service. So as you can see, it was imported successfully, great. Now we need to name our website. So we can use an existing domain if you have one with another domain registrar, or we can use the one in which we just created. In this case, mine is Chris Courses XYZ. I'll select that, and now we can finish setting things up. So our server location is going to be in North America. That's where I'm stationed. That is perfect because we're going to have the quickest amount of time to grab our game and bring it back to our client. We have our domain, and then we have our uploading file. All of this looks great. Let's hit finish setup and see how things look. And once that is done, you'll be greeted with a screen that looks like this. Really easy to get things set up. So we can go over here and view our website. If I open this up in a new tab, we're going to be greeted with something that looks like this. Totally fine. This is just a preview, and you can see when I click on this, we have chriscoursesxyz.preview-domain. So our domain is currently being set up, and we'll go ahead and manage it a little later. But if we want to see our actual game showing on that exact page right here, we need to check things out within our control panel. So let's go ahead and click Manage Site. And once we're within Manage Site, I want to go ahead and look at our file structure. And I can do that by clicking File Manager right here. So I'm going to go inside of File Manager and see how things look. And within File Manager, we have public_HTML. Whatever is inside of this directory should show on that URL in which we were just visiting. So let's double click this, and you see we have our vertical platformer folder inside of here, but really what we're rendering out is default.php. So let's go inside of vertical-platformer and make sure that these two files are actually directly within public_HTML. To do this, we can go inside vertical platformer, select these two files right here, and then click this move button. So I'm going to click that. And where do I want to move this to? Well, I want to go down a directory, so I'll click this. And now I know I'm inside of files/public_HTML. This is where I want to move things to. So I can click move. Those are going to move on over here, and I can delete default.php. So I'll delete that. But now when I visit our site, I should be rendering out what is in index.html instead of that default.php. So remember, this is what things looked like before. Now if I refresh, we have our Canvas game, but on a live URL. Pretty nifty stuff right there. Really, really easy to get set up. So if you ever want to update your site in the future with updated game code, all you need to do is drag a new index.html and a new index.js or whatever files are within your project directly within public_HTML, and your site will update automatically. Really, really easy. And we're going to do that at the very end of this course. Now, if you would like to visit your site at this actual URL, chriscourses.xyz, you can see right here that is not the actual URL. And if I try visiting that, chriscourses.xyz, we get server not found. We just have to make sure that we wait for our domain to actually activate, and it can take up to 48 hours. Just give it a little bit of time. Usually it never takes that long at all. It usually only takes at most an hour for me, at least in my experience, but we just need to make sure that we wait for that in order for that to show up again. We'll come back to this to make sure it's working once we upload our project, but that's pretty much all you need to do to get started with uploading your site up to Hostinger. To recap, if you'd like to upload newer files, just go to File Manager and make sure that you upload your new project inside of this public HTML folder. And you should be good to go with seeing your site on that URL. So we've taken care of that, and I think that means we can head back to To-Do and check off our domain setup. So next for our game, we want to create a player and basically have that player fall towards the ground with realistic gravity. How would we go about coding that onto our canvas? Well, we're going to start with an index.js, and we're going to create what is a player. Really, it's just going to be a red square. So how would I create a red square on top of our white square, which takes up the full width and height of the canvas? Well, I would do a c.fill style and set this equal to red to begin creating the red square. And then I need to define the actual dimensions of the square and where it is placed, which I can do with c.fill_rect. So I want this rectangle placed, let's just say off to the right by 200 pixels. Let's say this is going to be 100 pixels from the top of the canvas, and this is going to be a square that is 100 pixels wide by 100 pixels tall. With this, we can save, refresh, and there is our player. Great. We have a player on the screen, but now we need to actually animate it. We need it to start falling towards the ground because that is how our vertical platformer player is going to be moving around and look as if they are within a real world environment. So how do we begin moving that square down? Well, we need to start an animation loop because right now all this code is only ran on initial load. When we load index.js, we run this code once and that's it. We can't change any of the variables within here. So therefore, our player is going to stay exactly where they are. So if this is the case, we want to create an animation loop, which we can do by creating a function called animate. And this is arbitrarily named. I just call it animate because it makes sense. Well, this is where animation takes place. Call it animate. So within this animate function, I wanted to call something called window.requestAnimationFrame. And this is going to take an argument. Basically, the argument is what function do I want to call itself over and over and over again? Well, it's going to be the function that we're inside of, animate. So I'm going to take this name right here of animate and put it inside of requestAnimationFrame. And then down below, I want to activate this animation loop by calling our actual animate function. And now this is going to run as soon as I refresh our page. And let's test this out. I'm going to console out some text, just go, save and refresh, inspect our element, open our console tab, and you can see that this is just refreshing over and over again, going really quickly for as fast as this function can call itself. So how is this working? Well, we call animate down here, which in return calls the contents of this function. So immediately we're going to call requestAnimationFrame. This says call whatever function is inside of here. We know what we're going to call. It's going to be animate, which in return calls the function animate. What happens when we call the function animate? Well, we go through the process again. We're going to call requestAnimationFrame, which calls animate. So we're basically creating this loop cycle right here, which is going to keep looping unless we tell it to stop. But we don't want it to stop at all for our game, so we're just going to keep it running and begin animating our player downwards within this animation loop. So we know that this is working. How do we animate our player downwards? Well, for every frame, we can call our player's draw code, which are these two lines right here. If I take those and place them within our animation loop, save and refresh, nothing's going to happen at the moment because we need to say that this y variable right here, this y argument, is changing for every time we are calling animate. But right now it is just a static 100, so it's not changing at all. But whenever we want something to change over time, that is a great indicator that we need a variable. So let's create a variable in which we're going to change within our animation loop. To create that variable, I'm going to type let y. So our y coordinate is going to be equal to what? Well, 100 to start. Now that I have that declared, I can replace this 100 right here, our second argument with y, and now I can begin increasing this y let over time. So I'll say for every time we call animate, I'm going to add 1 onto the current value of y, and this is just shorthand for that. We're just adding 1 onto that new value. And if we save, refresh, now we are moving downwards towards the bottom of our canvas. Perfect. We have our animation loop and we're animating our player currently, but we have this drip effect. We want to make sure that we can always see the outlines of our player. And to do that, right before we call our player draw code, these 3 lines right here, we always want to make sure that we're clearing out our canvas. And to clear our canvas, we can take these 2 lines, which show the overall width and height of our canvas. I'm going to cut these from their current position, and make sure that I'm calling these for every time we call animate. So for our first frame, we're going to fill up our entire canvas with a white rectangle. Then on top of that, we're going to draw our red player. For the next frame, we're going to draw on top of our red player the full width and height of our canvas once more. We're going to call these 2 lines, and then we're going to draw our player again, but in the new Y position because we added 1 on Y. And that's just going to keep happening over and over again, but it's going to allow us to maintain the overall dimensions of our player. And you'll see what I mean by this shortly. Let's save and refresh. Now we can see our player. We don't get that drip effect, which was quite annoying before. But we are falling downwards, and eventually we reach the bottom of the screen, and we keep on going. And as we fall, this isn't truly gravity, because gravity is the effect of pulling down quicker and quicker over time. Right now we're going 1 set speed. If we wanted to actually simulate gravity, we need to make sure that we are adding on to our y velocity for every frame. So how do we go about doing that? Well, the first thing I would do is start transforming our code into object-oriented style. So right now we're just using procedural. We're just calling out c.fillStyle, c.fillRect, y++. And that's totally fine. We could continue using this. But let's say we wanted to add another player object. How would we do that? Well, right beneath this, I would copy these 3 lines, but now you can see I need to change things up a bit. I would need to change our x coordinate to something like 400 to give us some separation, and I don't want to use the same y coordinate as we're using for our first player. Therefore, I would have to create a new let up above, say that y2 is actually equal to 100 as well, and then make sure that I change y right here to y2, and change y right here to y2. It's very frustrating, honestly, if we were to do things this way and continue doing things this way. If I were to save and refresh, now we have another player, which is great, but this isn't very readable, and it's very annoying if we were to have to create another player in the future. We'd have to create another variable, assign a new variable name, and it's just really frustrating to do things this way, which is why we're going to go the object-oriented method. So, right beneath canvas.height, I'm going to create a new class called player with a capital P. That is a convention to just name your classes with a capital letter. You don't have to, but that's typically what I've been doing. And then every time I create a new player, we're going to call a constructor function. So whenever we create a new player, this function is always going to call. And what do I want to do within this constructor? Well, I want to specify the properties that each individual player will have within them. So properties such as this y coordinate. I know each of our players, right now our players are defined by these 3 lines, are going to have their own y coordinate. If that's the case, then I want to define within this constructor a y property. But instead of just defining a y property with this .y, I'm going to use this .position instead, because this way I can assign this .position equal to an x and a y property filled object. And this is just a lot more clear to me in regards to what position is, and it's a lot easier to use when we're actually referencing this property in the first place. So for now, this is totally okay, but now I want to define what a player looks like. We know what a player looks like right here with these 2 lines. A player is just a red rectangle, so I'm going to grab these, and then I'm going to create a draw method within our player class, right beneath constructor. Has an opening and closing curly bracket, and paste in those 2 lines. So whenever we call this draw method on a new player instantiation, we're going to call these 2 lines of code. But this is not going to work because now we don't have a y variable available to us. Instead of using just this y variable, we're going to reference our y position property, which now we can get because we defined it up above. So instead of referencing y right here, I'm going to reference this .position.y, and this is just referencing this value right there. So we're referencing that, but we might want to reference our x value too. So this is our x value. Whenever we draw out a new player, I'm going to reference this .position.x. We're going to draw at this x and y coordinate. Perfect. Now over time, we want to change these coordinates. How do we change these coordinates? Well, we're going to do that within an update method. And by the way, draw and update are both arbitrarily named. These are just conventions that I personally use, but constructor, that is something that comes with the JavaScript language. Just make sure that you know that. So I'm going to call this update because I know I'm going to update our Y property for every time we call animate. And to update our Y property, I'm going to call this .position.y and add 1 onto the current value. This is the exact same thing as we had down below. We can get rid of this y++ and our second player. And we can also get rid of these two lets right here, but now we need to actually create player objects from this player class. And to do that, right beneath our player class, I can declare a const called player and say that our player is going to be equal to a new player object. Right now, we're not taking any arguments. We're just trying to exhibit how this works in the first place. But now that we have a player object, we can use either of these two methods right here. So we have player, and now within our animation loop, we can call player.draw. We save and refresh, and now our player is being drawn, but it's not updating because we have not called player update, which in return is going to add on to our Y position. So now we'll call player.update right beneath this. Save, refresh, and now this is working just as it was before, but this is a lot cleaner within our implementation. We have player.draw and player.update. We know exactly what is happening here. But we could clean this up a little further if we would like. Within update, we can simply reference draw right there. So we'll say this .draw is going to be called whenever we call update. And now we can get rid of player.draw down below. We know that's going to be called within player.update. Save and refresh, and that's looking pretty good. Let's say we wanted to bring in the second player again. We just need to duplicate this line right here, 26. Say that this is going to be player 2. It's equal to a new player, which is going to give it a new position property separate from player 1. And then within animate, we can go player2.update. Save and refresh. And we do have two players on the screen, I promise you, but they're overlaid on top of each other because their x value is currently the same. Right now, we have an x value of 0 for both of these. It's static. So we want to make sure that we change this and make it dynamic. So to change this, I'm going to add in an argument to our constructor. It's going to be a position argument. And instead of assigning position to this object right here, I'm just going to assign position equal to the position we are passing through every time we create a new player. So right here, we're creating a new player. But instead of passing through nothing, I'm going to pass through that exact object in which I had up above. So our first player is going to have an x coordinate of 0 and a y coordinate of 0. But our second player is going to have an x coordinate of, let's say, 300 and a y coordinate of 100. We save and refresh that, and you can see that taking effect. So this is much more cleaner for our implementation compared to before, and I really recommend doing things this way compared to prior. But this doesn't solve our gravity issue. You might think gravity is just falling downwards at a steady, constant pace, but that is actually not the case. Instead of falling down at a constant pace, we're going to be getting quicker and quicker the further we fall down, and that's going to give off a realistic physics effect. It's going to make it look like as if this were occurring in real life. So let's head back to our code, and we're going to add in a property called this.velocity. And this is going to be equal to an object with an x and a y, because velocity can move a player either horizontally or vertically. So for our x velocity, we don't want it moving left or right. We'll just say that's equal to 0 to start. And then our y velocity by default is going to be equal to 1. So by default, we're going to be falling down. Now to make sure that our player's position is affected by this velocity right here, we're no longer just going to be adding 1 onto position.y. We're actually going to be adding onto this with plus equal this.velocity.y instead. So it's basically the same thing. We refresh, we get the same effect, but now we can begin changing velocity. For every frame we call update, we want to make sure that we are adding on to this velocity.y property. And as this gets larger and larger, it's going to push our player down further and further for every frame, giving off the illusion as if it's actually falling down in a real-world physics simulation. So right beneath this.position.y, I'm going to add in this.velocity.y, and I want to add onto this for every frame a steady value. So that value I'm just going to declare is 0.5. That is going to be our gravity value. And if I'm just doing this right here, save and refresh, you can see that already looks much more realistic than we had before. We successfully added gravity onto these player objects. But one thing I would note is 0.5 isn't very descriptive. If I want to know what this value is when I come back to this code at a later point in time, I don't want to use 0.5. I want to use a descriptive name, something like gravity. Now this is going to be global, so I'm going to define this right beneath canvas.height by saying a const of gravity is equal to 0.5. Now that's going to be used within our update method right here. Things should still function as before, and indeed they do. Now this is great, things are falling, but I want our players to stop as soon as they hit the bottom of our canvas. How would I go about doing that? Well, our player is going to be falling. Let's say this is the first frame. We go down a little bit, this is the second frame. Next frame, we're going to go down even further, the next frame even further, and the next frame even further. So if the bottom of our player right here is past the bottom of our canvas, we know that we don't actually want to activate this movement. We want to deny it altogether and make sure that we move back to the previous position, setting our y velocity back to 0. It's going to make sure that our y velocity is very small, something such as 0.5. If we only move by 0.5 from this position, we're going to move down a little bit, and this is going to keep increasing by that gravity value. Then we move down by 1, move down a little further, and then we move down by 1.5 even further. And if we ever go and cross this line again, what happens? We go back to a velocity of 0, and if we can't go down by 0.5 any further, well, we're just going to stop right here in the first place. So we want to detect for collision between the bottom of our player and the bottom of our canvas. If these two intersect, we're not actually going to move our player down here, we're going to set its velocity back to 0, which just means it's going to move back down at a slower pace, and it's going to create collision detection that we want, so our player is never going down past the bottom of our canvas. So let's start coding that out. So I only ever want to be adding on to our y velocity if a certain condition is true. If the bottom of our player is still above the bottom of our canvas. To write out that condition, I'll say if the bottom of our player, which I can get with this dot position dot y plus this dot height. So position.y is going to be the top of our player. It's basically the top of our red square right here. But I do want to add on this dot height to get the bottom of our player. That'll give us the bottom right here. But we don't currently have a height property. We hard-coded height into c.fillRect right here with 100. So instead of referencing 100, I'm going to code in a property called this dot height. And now I just need to make sure that this is available to us within our constructor by saying this dot height by default for every player we create is going to be equal to 100. So now we're using height to reference this right here, and we're also referencing height down here within our conditional. So if the bottom of our player, which we have right here, is less than our canvas height, which we'll get with canvas.height, then that is the only time we're going to continue adding on gravity to our y velocity. But we do need to take into account our y velocity within this equation. Because yes, we have the bottom of our player, but we are moving down at faster and faster paces using our y velocity. So we want to make sure that we add that in here. Included with the bottom of our player, I'm adding on this dot velocity dot y. So it's going to make sure that we're checking whether or not the bottom of our player on the next frame is actually moving past our canvas height. So if this is true, we're going to continue adding on to our y velocity with higher and higher values. But else, if this is not true, I want this dot velocity dot y set equal to 0. We're going to start off slow right here to make sure that we slowly hit the bottom of our screen. So let's see what this looks like with this if and with this else statement. I'll save, refresh, and now we just perfectly hit the bottom of our screen with a newly implemented gravity effect. And that's really all there is to it. This is never going to go past the bottom of the screen. We're always going to stop as long as we have this condition in place using the bottom of our player, the bottom of the canvas, and velocity.y. So that means we can go on over to to-do and successfully check off gravity. So by default, we have gravity pulling down our player, but really it only makes sense to begin adding player input so we can move our player around. That's definitely going to be needed for our game. So how do we begin adding that in? Well, within index.js, we're going to want to add in what's known as an event listener. It's going to listen for things such as click events, key down events, whatever it might be. But in this case, we're going to listen for that key down event so that whenever we press a key on our keyboard, whether it be an arrow key, a W key, and a D key, those are pretty typical for movement, we move our player around. So how do we begin listening for those keys? Well, underneath animate, I want to add an event listener, which I can do by calling window.addEvent listener. And now this is going to take an argument. The very first one is going to be a string of what event do we want to listen for. Well, I want to listen for a key down event. Whenever we press down on a keyboard, what are we going to do? Well, I'm going to add a comma and then add in an arrow function that says we are going to respond with the following code. Whenever we key down on any key on our keyboard, we're going to call whatever is inside of this arrow function. So I'm going to console log out an event object, which we can pass through as an argument right here within our arrow function. So if I save, refresh, and inspect our element, and go to our console and begin pressing down on any key on our keyboard, A, S, D, F, you can see I'm console logging out that event. And we have a few properties inside of this keyboard event, such as what key are we pressing down. You'll see I press down A, I press down S, I press down D, and I press down F. So if we listen for these exact keys, we can respond in different ways. If I press down the D key, we can move our player to the right. If I press down the A key, we can move our player to the left. You kind of get the idea. So we just need to make sure that we're listening for the different keys we're pressing down and then react to these key presses in different ways. So within this key down event listener, I'm going to call a switch case statement, which looks like this. I'll call switch and say that I want to switch out event.key because this key property right here references what key are we actually pressing down. Switch event key, opening and closing curly brackets, case, string, and what key do I want to listen for? Well, let's start off with our D key. This means we're going to go to the right. If I type D right here, I can add a colon right after this case, and then add in a break, and anything in between this case and break is going to be called whenever we press the D key. Only the D key though. So let's console log out. I'm moving right because that is what's supposed to happen when we press down D. I can save and refresh. And now I'm going to press A, I'm going to press S, nothing's happening. But when I press down D, now we're moving to the right, or we should be at least. So let's actually code in that functionality where we're moving to the right whenever we press that D key. So what we want to do is whenever we press D, is we want to add on to our player's X velocity. Not the Y velocity, but the X velocity. And when we do that, we should be pushing our player over to the right. So let's do this preemptively. Within case D, I'm going to reference our player dot velocity on the x-axis and set this equal to 1. So as long as that's set equal to 1, we should be moving to the right, right? Well, it's not going to be the case right now because we actually haven't implemented any x velocity within our update method right here. So yes, we are affecting our y velocity and our y position, but we want to do the same thing for x. So I'm going to copy this line, paste it, make a duplicate, and instead of referencing position.y, I'll reference position.x and add on to this velocity.x, whatever that might be. There's not going to be a default up here. This is just going to be set whenever we press down D for the time being. So let's save this, refresh, and then hit D, and you see we're automatically moving to the right. Really, really cool and really easy to get started with. Let's say we want to start moving back over to the left. What would we do? Well, we would create a new case. I'll just copy these 3 lines right here, paste them down below, and I want to listen for a case of A. So when we press down our A key, we're going to move backwards by setting our x velocity to a -1. We save that, refresh, hit D, we're moving to the right, and now when I hit A, we're moving back to the left. But you'll see my hands are off the keyboard and we're still moving. That is kind of annoying, and we will fix that very shortly, but let's take care of a jump first, because I think this is going to be the most interesting thing when it comes down to player movement. So to listen for a jump effect, we want to listen for a W key. That is usually the key for jumping within most games. So I'll copy a case statement, paste it down below, and listen for a case of the W key. Now whenever we hit down W, I don't want to affect our X velocity, but rather our Y velocity, and I'm going to send us upwards by a big value, something like -15. And if I do that, watch what happens. I'll save and refresh, and then I jump. You're going to see we go up pretty high, and we immediately fall back down because we already implemented gravity into our whole physics simulation right here. It's just really cool and really easy to implement that jump effect because we don't really need to do anything else. All we needed to do was set our player.y velocity equal to a negative value, and if you wanted to make this something even greater, such as -25, refresh, you see that you're going to jump way higher. But I think for the time being, maybe I'll just keep this at -20, and we'll come back to this and fine tune it later as we continue developing our game. So let's stop our player from moving over time. To stop our player from moving, I always do this the same way. I basically create a const above animate called keys. And keys is going to be equal to an object. This is going to contain all the keys I want to listen for within the game, at least keys that I'm going to be inputting with. So the first key I know I'm going to be inputting with is going to be D. And this is going to be equal to an object. And inside of this object, I want to tell whether or not this D key is pressed down. So I'm going to add in a property called pressed, and by default it's not going to be pressed, so I'll set it equal to false. I want to do the same thing for our A key. So I'm going to duplicate that object, replace D with A, and by default, that is going to be equal to false. Now I only want the set equal to true when I actually press that key down. So instead of changing our player velocity within the event listener, I'm going to delete this line right here, and then instead say, I want to select our keys, specifically our D key, and say that it is pressed down. So dot pressed will be equal to true. I'm going to do the same thing for our A key. Let's delete this line right here, paste in keys.d.pressed, but set D equal to A instead. Now that is the first step, but what happens when we release these keys? Keys A and keys D.pressed will both still be equal to true. We need a way to set them equal to false, and to do that we're going to listen for a new event. It's going to be key up instead of key down. So if we want to do this real quickly, we can simply copy this event listener, and down below, paste it, and reference key up instead of key down. Now we don't want to listen for a key up event for W, because we're only activating this jump when we press down, so let's delete the W. And now, whenever we key up on D or A, whenever we release the keys, we're going to set those equal to false. So now we have a way to track within our animation loop which keys are currently pressed down and which ones are not. So within animate, I now want to listen for those keys, and then I'm going to affect our player's velocity based on which is pressed down and which isn't. So here, the first thing I'm going to do is set player.velocity.x equal to 0 for every frame we go through. But if our keys.d is pressed, we're currently pressing it down, then our player.velocity.x is going to be equal to 1. So only if this is pressed down are we actually moving our player, and then calling update, which actually moves the player. But I also want to listen for if the A key is pressed. I'll say else if keys.a.pressed is true, then our player.velocity.x is equal to -1. So if we ever lift up on these keys, these conditionals will not be true, which means for the next iteration of our animate loop, player.velocity.x is going to be equal to 0. We're going to stop moving, which is exactly what we're looking to do. So let's save this, refresh, and begin moving by pressing down D. You can see I'm moving to the right, but if I let go, we stop because we set player.velocity.x equal to 0. If I press A, and let go, we stop because it's now equal to 0. So really we're just making sure that we're changing our velocity within the animation loop rather than directly within the event listeners, and it's going to allow us to make sure that we're setting this back equal to 0 when we need it to be 0. But if we ever do want to make sure that our player is moving a lot faster than they are right now, we just need to change these values right here. Let's change them to something like 5. Refresh, and now we can move across our screen in a much more realistic manner, something that's a lot more fun to play with than just moving one pixel at a time. So I really like the way this is looking, so as a result, I think we're going to be able to go back to our to-do list and check off player movement. So now we're going to add a background sprite into our game. We need to start adding images, so this is going to be the most basic one we can add. So how do we go about getting this sprite in the first place? Well, check the link in the description because I have a link to a Google Drive folder, and inside of here you can get all the assets for this game. So right here we have background.png. I'm going to right click it and then hit download, and that's going to download to my computer. So once that goes ahead and downloads, we want to add it to our project. So I'm going to open up two Finder windows. We have this one in the top right, and then we have this one in the top left. So obviously that went to my downloads folder. And we can see right here, background.png is there. I want to drag it on over to our vertical platformer. So I'll drag that on over there, but I want to put this inside of some sort of folder to make sure that things are organized within our project. So I'm going to right click, hit new folder, and I'm going to call this folder img for images. So all of our images are going to go inside of this folder. So now I can drag background.png inside of it, like so, and we are good to go. So if we look over in Sublime Text, we have an image folder, and inside of the image folder we have background.png. Looks a little something like this. This is going to be the background for our game. So how do we actually plop this into our game? Well, to do so, we are going to create a new class specifically for a sprite. A sprite is basically just an image. It's just game terminology for it. Sometimes these images move. We call them sprites within game development. So to get this into our game, I'm going to create that new class within index.js right above our player class. So right above player, I'm going to say our class of sprite with a capital S is equal to opening and closing curly brackets. Well, not equal to, but just has opening and closing curly brackets. So a sprite is going to have a position associated with it. We might want to place this image starting from the top left-hand corner of our canvas or somewhere completely different across our game. So we know we're going to have a position, and if we have a position, we're going to create a constructor which passes through a position argument, and then we need to assign a property to the sprite that says this dot position associated with the sprite we're about to create is equal to the position we actually passed through the constructor. Great, so we have a position associated with a sprite. What does a sprite look like though? Let's start by creating the sprite's draw method. So we'll add in a draw method that says a sprite should look like what? Well, we're going to call our canvas context with C, and then call C.draw image with a capital I, and this takes 3 arguments. The first is going to be a JavaScript image object. So we don't have that just yet, but I know we're going to create it, and it's going to be stored inside of something called this.image. That is an image property associated with our sprite, but it also takes a second and a third argument. The second argument is going to be the x position of this sprite, which we can reference with this.position.x, and the third argument is going to be the position on the y coordinate. So I'll reference that with this.position.y. So this is what our sprite is going to look like. All we need to do is call c.drawImage, but this isn't going to work unless we actually have a JavaScript image object stored inside of this.image. So over in our constructor, we'll add in another property for this sprite that says this.image is equal to a new image object. This image object comes with the JavaScript API by default, and we can use it to create images and then draw them within Canvas by using this method down below. So this is a good start, but in order to actually assign an image to this.image, we need to reference this.image.src, which is now available to us because this.image is now a new image. We want to set the source of our image. Where is the image in which we want to reference? Where is the image we actually want to draw out and render on our canvas? Well, we need to specify that. Each sprite is going to have its own individual image most likely, and if that is the case, that is a good indicator we want to pass that through as a constructor argument. So we can add a comma right here that says image src is also going to be passed through. Now, typically, I don't like passing through my arguments like this because I have to remember the order. This requires that I pass through a position first and then image source second, and it can get kind of hard to remember, especially when we start to expand this constructor function even further. So what I like doing is wrapping these within an object, one singular object, with opening and closing curly brackets. And if I do things like this, well, one, these arguments are more descriptive because when we create the object, we have labels for what we are assigning position and image source to. You'll see that very soon. But also, it does not matter which order I pass image source or position through. I always like doing things this way. It is much more easier for me to manage within my code base, so that is why I am wrapping these within curly brackets. Now, we're passing through an image source, and I want to set this.image.src equal to that image source we are passing through. Now, this is a great start, but before I actually create a new sprite and call the draw method, I do want to add a conditional to this draw method that says if this.image does not exist, so we actually haven't instantiated and loaded in our image yet, then I just want to return altogether. Because if we try calling c.drawImage while this.image is equal to undefined, meaning the image has not loaded yet, we're just going to get some errors in the console. We don't want that. So this if statement will prevent that from happening. Now, it is also likely we will update this sprite in the future, maybe on the X position, Y position, or even the frame that we're currently on. And if that's the case, we want to make sure that we add in an update method that calls this.draw, or just preemptively doing this. We don't really need this right now. We could just create our sprite, call the draw method, and be done with it. But I'm pretty sure we're going to be using this update method later on, so I'm just going to add this in for now. Keep things consistent with our player class. So let's add in our background sprite. How do we go about doing that? Well, down here, within our implementation, I'm going to create a new const called background. And this is going to be equal to a new sprite. And so we have one argument within our sprite constructor now because we wrapped it within those curly brackets. It's going to look like this. We have the curly brackets, and then we need to specify what properties are we trying to pass through into this new sprite. Well, let's look up above in case we forgot. We have position and we have image source. So we need to list those out right here. Our position property is going to be equal to an object with an X and also a Y. I want this drawn in the top left-hand corner of our canvas, so I'm going to set both of those equal to 0. And you can see by using this object syntax, Now we know exactly what we're assigning right here for the first argument, which is position. We're assigning position equal an object with an x and a y. If we were not using this object syntax, well, position wouldn't exist, and we basically just be passing through this xy object right here. We might not know what it means because we don't have a label associated with it when we use syntax like this. So that's the whole reason for me using those arguments over in the Sprite constructor. But we do know we also need to pass through an image src. Image src is going to be equal to the source of the image we want to reference, and we can get that by going inside of our image folder, which we'll do with ./img, and then add in an additional slash, and then reference background.png. That's all we really need to do to get started. So let's call background.update within our anime loop, and we want to draw this out before anything else like our players are rendered, because otherwise, if we call this after our player update functions, well, our background would basically cover our players. We don't want that. We want this in the background, not the foreground. So right before these player and player 2 updates, I'm going to call background.update, and given everything went according to plan, we should see our background being rendered out on the screen. Let's save, refresh, and there is our background. Really cool stuff right there. But obviously this isn't taking up the full width and the full height of our canvas. The artwork for this background was created using a tile set which is much smaller than your average tile set. This one was created using 16 by 16 pixel tiles, and most of the time you would get 64 by 64 pixel tiles, which makes sure that your background artwork takes up the full screen, or whatever artwork you're trying to use within your game. But this is totally okay. I do want to show you how to scale up images like this and any other artwork you might use in your game to make sure that it fits accordingly. You don't have to be limited to your artwork just because you got something that was smaller or larger than what you might use. So we're actually going to scale this on up to make sure that it fits our screen right here. And we're going to be panning around this whole scenery using a camera which we'll develop later on. So over here I'm in Adobe XD, and I'm using this to help illustrate how we're going to scale this image up and then translate things so that it's placed in the perfect position for our player. So right now, our image is 576 by 432 pixels. And this is what it looks like on top of our canvas, represented by this white rectangle, 1024, 576 pixels. So we want to scale this up by 4 times. What would my dimensions be if I scaled this up by 4 times? Well, we can take our width right here, which is 576, and then I'm going to plug this into a calculator real quick, multiply it by 4, and we are going to get 2,304. If I scale that, we're going to get something like this. So let's just start by scaling up our image so that it looks like this on top of our canvas. All we're going to see are these 3 platforms right here. How do we do that within our code? Well, we want to focus on where we're updating our background. We know we're drawing out our background right here, so we're going to scale up just this one portion of our code. And to scale up just this one portion, we need to use something called c.scale. And then we need to determine on the x-axis and the y-axis, how much should we scale this up by? Well, I want to scale this up by 4 times the original amount on the x-axis, so I'll put 4, and also the y-axis, so I'll put 4 right there as well. And if I save, refresh, well, something just did not look right there. We are continuously scaling up that one portion of our code over and over again because we're repeatedly calling this within animate. If we only want to scale up just one portion of code, specifically this background.update method, and only once, we need to use something called c.save and c.restore. So right before I call c.scale, I'm going to call c.save, and right after I call background.update, I'm going to call c.restore. When I use these two in tandem together, when I call a global method like c.scale, I'm only going to affect whatever code is within c.save and c.restore. Everything else is not going to be affected. So what I'm doing right here is specifically saying I only want to scale up background.update and whatever draw method is inside of there. And we know what draw method is inside of there. It's going to be c.drawImage with the image that we imported using background.png. So let's save this, refresh, and now this is looking exactly like we have over in Adobe XD. As you can see, this matches up quite nicely with what we have in our canvas. So that is going to be step 1. But we do want to translate this down so that we start at the bottom of our map. We want to move this up so that we're starting down here rather than at the top, because this looks like a nice little start zone. Not so much the tops of the platforms. Maybe you want to start at the top. But to me personally, I think it makes more sense to start down here. So what we want to do is take our background image and translate it upwards. How much do we want to translate it upwards by? Well, let's just say we're translating it upwards by the full height of this image, which right now is 1728. Let's move it all the way up by the full height of the image. If we move it all the way up, we're not going to see anything at all, and that's totally okay. So we're going to move it upwards by the full height of the image, and then we're going to push it down by the height of our canvas. If we add on 576 pixels to this current location right here, what's going to happen? Well, this is going to be placed perfectly where we want it to be within our canvas. So that is the formula for making sure that this is placed at the bottom rather than at the top. We're going to translate upwards by the full height of the image, and then we're going to translate down by the height of the canvas. And I should note we're translating down by the height of the scaled canvas. And I should note for this to work in Canvas, we're not actually translating by 728. We're translating by the original dimensions of this image, which I can't remember what they were. Let me do the math real quick. It was 1728 divided by 4. So the height is going to be 432. We need to make sure that we're translating by that to the original dimensions. Otherwise, things aren't going to look correctly. Scale right here does not affect the original dimensions of the image and how much we're about to translate by. So it's very important to keep that in mind. But nevertheless, let's go ahead and get translating. So within the same c.save and c.restore, I'm going to call right after c.scale, c.translate. How much do I want to translate this whole image by? Well, on the x-axis, I know I don't want to translate this at all, so I'll put 0 right there. But for the y-axis, I want to translate by the height of the image. So to get the height of the image, I'm going to use background.image.height. That'll give us the height, but we do want to move this upwards, remember. So to move this upwards, I'm going to assign a negative value to this, and then we want to add on the canvas height. But we don't want to add on the original canvas height right here, which is 576. We want to add on the scaled version, which is this divided by 4, because now we're in a scaled mode. So let's go ahead and create a const called scaled canvas and set this equal to an object with a width equal to canvas.width divided by 4. That'll give us the scaled down version. Then we also want the height set equal to canvas.height divided by 4 as well. So that's going to give us scaled down versions for both width and height. And now I can use that within our equation down here. So I'm adding on to background image height, scaled canvas.height. And that's going to make sure that we're pushing back down on the image so it's in the perfect location within our canvas by the exact amount relative to the scaled values that we're using. So let's save this, go over to our game, refresh, and there we go. We're at the bottom of our canvas. We can move around. It doesn't look that realistic just yet because we're not even really on top of this ground right here, but we'll be fixing that shortly as soon as we add in collision blocks. But for now, this is a perfect way to get a sprite into the game, specifically our background sprite. So let's go back to our to-do list and check off background sprite. So the next thing we're going to add into our game are collision blocks. So what are collision blocks in the first place? Well, let's check out our game over here. Collision blocks are going to be blocks in which we collide with. It makes sense, right? So what I mean is, basically, I want to draw out a couple of blocks on our map in various locations in which I know I want our player to collide with. So this would be a location, this would be a location, this would be a location, and I'm going to keep drawing these blocks out all the way across our ground right here so that our player is placed on top of these blocks and doesn't fall beneath them. Same thing goes for this section up here. I want our player to be able to jump on top of this section, not fall down towards the bottom of our screen. So that's what collision blocks are going to do, is allow us to collide with these to begin creating a layout for our map. We're going to create collision blocks right here, and then eventually we're also going to create platform blocks in which we can jump up through but land down on top of. So how do we get started by creating these collision blocks? Well, one thing we could do is just code these blocks out manually. We could create a large collision block in the very bottom right here and then code the necessary collision detection to say our player should be standing on top of this. But that is very time consuming. So instead what we're going to do is use a map editor called Tiled. So Tiled looks a little something like this over on the right hand side. And as you can see, I already created this map in a tile-like grid. So if you'd like to know how to use Tiled, I do have a course on that. You can check out my Pokemon course in which I'll teach you how to use Tiled. Video is going to be right there in the top corner. But to give you a gist on how this works, basically I can select tiles over here with my tile selector, and then draw them on in different locations on my scene to create a map. This is a really great way to create maps quickly. But the main thing I want to show you is these collision blocks, which are these red blocks on our screen. So the collision blocks I can turn on and off by selecting this layer, either floor collisions or platform collisions, and I made these layers myself. You can see I can turn them off with this little eye tool. And when I turn them off, the red blocks go away. So basically, in every location I want our player to be able to stand on top of or collide with, I drew out these floor collision blocks using this collision tile right here. And I drew them all the way across the bottom of our map floor, and right here in this little area in which I know I want my player to collide with. Now something else to note is I also included platform collisions for all of our platforms up above. I could toggle that on and off, and these platform collisions are there so that I can jump up through the platforms and then land on top of them. I need to make sure that I separate these because I'm going to code the platform collisions differently to make sure that we get that effect where we can actually jump up through them. So this is what Town looks like. Essentially what we need to do is grab these floor collisions, get the data associated with them, and import them into our game. So let me illustrate this a bit better. As I just mentioned, we need the data associated with each of these tiles, specifically for our collision blocks. Now each of these little tiles has a bit of data associated with it. What we're going to do is loop through every row available to us on tiled. So we'll loop through the first, we'll loop through the second, we'll loop through the third, and then eventually we're going to loop through what is the fifth row right here. And when we loop through the fifth row, we're going to get a data value that is different from all these other rows. Let's say this data value where our collision block is has a symbol of 1 compared to 0. So all these other blocks, I'm going to say, have a data value of 0. All these are 0 because there is nothing in them. But this block right here, we know there's a block there, so we're going to give it a data value of 1. We go to the next block, we give that a data value of 1. This is a data value of 1. And then there's nothing right here, so we give it a data value of 0. So we're going to be looping through all these tiles, and if we hit a collision block with a data value of 1, then we know this is where we want to draw a block onto our actual game over here. And to make this effect happen, with our tiled grid, I made sure that it was the exact size as what we have over here in our actual game. You'll see this is relatively similar to what we have over here because I exported this image directly from tiled to import into our game. So within our game, we're going to loop through all the rows, and then eventually once we hit a collision block or a platform block, such as right here, and right here, we're going to draw out that block and then code the functionality to make sure that we can actually collide with these blocks. So if that's a little confusing right now, don't worry, I'm going to walk you through every step along the way in regards to how to do this. So the first thing we need to do is make sure that we're actually exporting the data associated with each of these collision blocks. And to do that, we can make sure that we have tiled selected, and then go up to File, Export As, and I want to export this as a JavaScript map file. This is just going to give me one large JavaScript file full of data associated with our tiled project, but we only need a little bit of data from here, but there's no way to export just that data alone. So we're going to export it as a full thing, and I'm going to call this our vertical platformer map. And I can save it as that, and once I save it, I want to open up our Finder, and you can see right here, I just exported that, and now I can open it up in something like JavaScript. So I'll do that now, open that up, and here is what it looks like. So this is just one large data file, but we only need the data associated with one of our layers. What layer is that? Well, I want to start with our floor collisions, so I'm going to do a Command F within this file to find our floor collisions, and there it is for me on line 278. So if I scroll on up within this object, you'll see that I have a ton of zeros right here laid out within a data array. I want to grab this whole array and import it into our game, because as I mentioned, all these zeros just means do not draw anything in this spot. But if we hit something like a 1 or another symbol like 202, that means we want to draw a collision in that exact location. So for this data, 202 is going to be the one that represents where we draw a collision block specifically for our floor collisions. So let's start by grabbing this full array right here. I'll go from the top all the way down to the very end, and I'm just going to hit Command C to copy that. And once I have it copied, I can go back to our game, and I need a place to store this. I don't really want to store it within index.js because that's really going to muddy up my file quite a bit. So I'm going to create a new folder for this, and that folder is going to be called JS. All of our JavaScript files are going to go in here from now on, and then I'm going to create a subfolder, which I will call data. And then within this data folder, I want to create a file called collisions.js. So you can see all that was created for me right here. And once I have this created, I can paste in that data array. Now I do want to store this to a const so I can use it within something like index.js. So I will create that const and say that this array is going to be called floor collisions and assign it like so. Hit save, and this is what our array looks like. So you can kind of see when this auto-formatted how things are going to work. We're going to cycle through all these zeros, And eventually when we hit these 202s, that's when we want to render out a collision block. Now it's important to note that this whole array right here is just one large array full of data. There are no subarrays within this to represent rows. And that's going to be the next step. We need to transform this into a two-dimensional array so that there are going to be arrays within arrays. Why do we need to do that? Well, we need to make sure that we're looping through this data so we can grab values related to the x-axis and also the y-axis. We want values associated with each row and each column so we can place these blocks in their precise locations within our map. To help illustrate this, I'll bring back tiled, full screen this, and zoom in a bit on our map right here. So the way we exported all of our data, we have zeros, and we just keep on continuing with these zeros. And we just keep on going past the map because we don't have a way to tell when to go on to a next row. What I want to do is, instead of just keep going on with zeros and zeros, is I want to take these zeros and put them within their own array for each row that we have within our map. So all of these zeros would go within their own array all the way to the very end. And then once we reach the very end of this row, we create a new array and then add the zeros as necessary. And once we hit this row with collision blocks, that's where a 202 would go, something along the lines of that, and so forth until we hit to the very end of our grid down here. So by parsing things into a 2D array, we're going to be able to precisely place these collision blocks. Since things are exported into a 1D array by default, we are not really able to do that easily, so it makes sense to transform this into a 2D array. Let's start by doing that. So we know we have our floor collisions right here, which is the 1D array. It's just all of our data in one singular data type. And I want to import this into index.js so we can begin parsing it. To import this, I want to go to index.html and create a new script tag that references that data file of collisions.js. So instead of referencing index.js twice, I will go inside of our JS folder, and then I will go inside of our data folder and reference collisions.js. And if we did this correctly, now within index.js, we should be able to reference our floor collisions array. Let's test that out. I'm just going to console log floor collisions. This is the const that we created within collisions.js. Save and refresh, and then open up our console, and we should see all that data logged out within a singular array. This isn't actually in subarrays. This is just the way that Chrome parses this out when logging things, but you can see all of our data is there. Perfect. Now we can begin parsing this into that 2D array. So how do we do that? Well, I want to create a const to store this 2D array in the first place. And that const is going to be called floor collisions 2D, and it will be equal to an empty array to start. We're going to push in subarrays into this new parent array. So to push in those subarrays, I want to loop through our data for every 36 tiles, because that is how long a row currently is within our map over here within tiled. This is 36 tiles wide by 27 tiles tall. So I know once I've gone through 36 pieces of data, I can push that into its own array, and then go on to the next 36 pieces of data and create a new row with all of that. We're just going to keep doing the same thing until we hit the very bottom of our actual tile set down here, which is 27 tiles. So let's begin doing that. I want to loop through all of our data and say for every 36 tiles, I want to create a new subarray. To do this, I'm going to create a for loop that starts with for let I is equal to 0. This just means we're starting at the value of 0, and I want to run this for loop for as long as I, our index, is less than our floor collisions, not 2D, but just our floor collisions dot length. So the full length of collisions.js over here. And then I want to say for every iteration of this loop, I want to add on a value of 36. That's going to send us over to the next row to begin pushing in new pieces of data. So here I can say for every iteration, I want to add on to I a value of 36. Now what I can do is, for every iteration of this loop, grab our floor collisions 2D array and push into it a new subarray. To create a subarray, I can use an array slice method. It's going to look like this. We'll select our floor collisions, the main 1D array, and then add on that slice method. That's all we have to do. So we're basically going to be slicing out a portion of this array right here, slicing out the first 36 items until we go on to the next iteration, which will slice out the next 36 and place all these within their own arrays. So where do we want to begin slicing within our floor collisions array? Well, at the very first index value to start, that's going to be I. We're going to start at a value of 0. But where do we want to slice up to? Well, let's think. If we take I, which is currently 0, and add on to this a value of 36, we're going to go from 0 to 36 and grab those first 36 items. That is perfect for the first row of our 2D array. But what happens when we go into the next iteration of this for loop? Well, we're going to increase I by 36. That means for the next iteration, I right here will be equal to 36. If we add 36 onto I, what do we get? 72. We successfully grabbed the next 36 items within the array and pushed them into their own subarray within Floor Collisions 2D. And this is just going to keep running until we reach the very end of this array right here, and it will perfectly parse out everything into its own 2D array. So let's save this, and then console log out Floor Collisions 2D to see the end result and make sure that we did this correctly. I save that, refresh, and you can see right here we have 27 rows of data full of subarrays, which are 36 columns wide. That is exactly what we want. We successfully parsed this all out into the perfect format to match up the collision blocks of what we had over in tiled with what we have right here within our game. And you can see once I start scrolling down, while these 202s are starting to resemble the same shape in which we originally had within the tiled set. It looks a little something like this. This right here kind of matches up with the 202s that we have over here. So that is exactly what we want. And now we can loop through this 2D array to make sure that we're creating collision blocks in this exact location right here. So how would I begin looping through this array to start rendering out collision blocks? Well, here is how I would do it. We know Floor Collisions 2D is pretty much set. We're good to go on that. So we can grab it by selecting Floor Collisions 2D and begin looping through it with a dot for each method. So this is an array method. This says for each item within Floor Collisions 2D, what do we want it to do? Well, we're going to start by creating an arrow function and grab the item we're currently looping over. So we know our items directly within this array right here are going to be arrays. What does each array represent within this? It represents a row. So it makes sense to call this item a row right here. This is arbitrarily named, but I always want to make sure I'm naming things descriptively. So a row is a good description of what we're currently looping over. And once I select each row, I can loop through each row's items within. What does one of these zeros represent, or one of these 202s? These are symbols. So I'm going to say I want to loop through each row's symbols by saying row.for each symbol within our row. I just want to loop through those symbols, and I can console log this out so we can see exactly what is going on here. So save that, refresh, and you can see right here we have about 792 zeros, 3 202s. We keep going through this until we hit the very end of our arrays. What we want to do is say for every time we hit 202, we are going to draw out a collision block. So within this row for each, I could say if the current symbol we're looping over is equal to 202, we want to draw out a block. I'm going to console log out draw a block here. Save and refresh. So there are 38 locations in which we want to draw a block. Let's begin doing that. How would I draw out a block in this location? Well, I want to create a class so I can begin creating block objects in which our player can interact with, because it's going to make that collision detection a lot easier than if we were to do things procedurally just by drawing out blocks with c.fillRect right here. So we know how to create classes because we already created a sprite and a player class, but if I were to begin creating a class right here, it's really going to make our file a lot larger than it needs to be. If you're finding that things are hard to navigate within your file, that's usually a good sign in which you should start refactoring things into separate files. And for me, I don't like having to scroll around a lot just to get to my implementation. I really like separating my classes from the actual implementation of my code right here. So in this case, I am going to start refactoring our classes into their own separate files to make sure that our code is readable and as maintainable as possible. So let's begin doing that. To start, I'm going to go to File, New File, and this is going to be our Sprite class. I'm going to cut this out of index.js, like so, select class to the very end, save this file, and then paste this within our new untitled file. I want to hit Command S to save this. And where do I want to save this? Well, it makes sense to put this within our new JavaScript folder, and I'm going to create a new folder within this for our classes. Now within this classes folder, I could say this is going to be our Sprite class, just call this sprite.js, and now we have a location in which sprite.js is saved. And you can see our file is already a lot cleaner just by moving that over. But we can do the same thing for our player class. Let me grab that player class, and then create a new file, paste that in, hit Command S, and then within JS, within classes, I'm going to save this as player.js. Perfect. So now we have two classes here, and really index.js is just going to be our implementation. But if we were to save and refresh this, things would not work because we have not pulled in player.js or Sprite.js after transferring them to their own files. So we want to make sure that we do that within index.html. Let's do that by copying the script tag right here, pasting it, and then say we want to pull in, not from the data folder, but rather our classes folder, a file of player.js. And then I want to do the same thing for Sprite.js. I want to make sure that we pull that in. So I'll duplicate a script tag and replace player.js with Sprite.js. As long as we do this, save and refresh, things should still function as expected, in which they do. So perfect. We definitely organized our file a bit, but we do want that new class for our collision block. Let's begin creating that. I'll create a new file and immediately save this as collision block within our JS folder, over within our classes folder, hit save, and it looks like I did forget the extension on that. We can just rename that file to include that JS, and we are good to go. So a good starting point is we can copy one of our other classes and begin working off of that. I typically find that to be the fastest way to whip up a class. So let's grab our Sprite class, for instance, copy this, and paste it within our collision block file. I just need to make sure that I change the syntax within Sublime Text over to JavaScript, and we have that coloring back. So I do want to change Sprite over to the name of collision block. And I know each collision block is definitely going to have a position. We don't need to write that code out for position. We are not going to use an image though. We can get rid of this and get rid of image source because a collision block is just going to be a red rectangle. We don't need any images associated with that. But how do we create that red rectangle within a class? Well, I think in this case, it makes sense to create a height and a width property. Let's start actually with the width property. A collision block is going to have a width associated with it. And what is that width going to be? Well, really it all comes down to the width of the tile, in which we used over here, which this tile set is 16 pixels by 16 pixels for every tile that we're drawing within this grid. So we want to say that our width to start is going to be 16, and then this dot height is also going to be 16. Now that we have these properties in place, we can determine how we want a collision block drawn out by editing its draw method. So I'll get rid of this other code we were using for our Sprite class and say, I know I want a collision block to be drawn with c.fill rect. And we're just going to draw a simple rectangle by referencing the position associated with the collision block, which we can grab with this .position.x for the x coordinate. We'll get the y coordinate with this .position.y. And then we need the width and height to draw this block out. So the third argument will be this .width, and the fourth argument will be this .height. Now I do want this collision block to be red, and also to be a little bit transparent to match what we had over in tiled. And to do that, we can declare we want our c.fill style equal to RGBA, so red, green, blue, alpha values. Now, this is going to run any value from 0 to 255 for each argument we're using in here. How strong do I want our red color to be? I want it to be as strong as possible, so I'll go towards the max of this range, which is going to be 255. And I don't want any other colors mixed into this red. So I'll do the lower range of this, which is going to be 0 for green, 0 for blue, and then for alpha, this is going to determine how transparent this color is. I want it to be moderately transparent, so I'll just say this is going to be 0.5. And that should get things drawn out correctly regarding our collision block. Now we just need to actually create these collision blocks within our game on those exact locations in which we looped over a 202 symbol. So here's how we're going to do this. We're going to go over to index.js and find where we're looping through our floor collisions 2D. So whenever I hit the symbol right here, I want to push a new collision block into a collision blocks array, and then we're going to render that array out. So right above this, I'm going to create a const called collision blocks. This is going to store all the collision blocks we're about to create. Now I know whenever I loop over this symbol, this is when I want to start pushing in a new collision block. So right here I'll say, let's grab our collision blocks array and push in a new collision block. We know this is going to take one argument. It'll be a position that has an x, set that equal to 0 to start, and also a y, which we will also set equal to 0. So perfect. Now by default, this code will not work simply because we actually haven't imported our collision block class into index.html. We need to make sure that we do that if we want to use it within index.js. So let's copy the script tag right here, paste it up above, and then we'll replace Sprite with collision block, and now that should be imported into index.js. Now, how do we begin determining where we want to place these collision blocks? Well, it's all going to be based on the current index of each row and each column in which we're currently looping over. So I want to start by grabbing the row index. What is the row index over here within tiled? Well, the row indices are going to be over here on the left. It's going to start on 0, 1, 2, 3, 4, and we're going to go all the way down to the bottom of our map until we hit 27, because that is how tall this map is in regards to tile size. So we want to grab that row index, and then we also want to grab the column index. Column index is going to start up here, start at 0, 1, 2, 3, until we hit the very last column index, which will be 36. So we're going to use these indices to determine where we want to draw out each individual collision block. So right now we're only drawing out the floor platforms. When we hit something like 26, 25, 24, 23, we're going to say that the Y value, whatever collision block we want to draw, let's say we're starting up here, the Y value for this collision block is going to be 23 times 16. When we multiply 16 by 23, we're going to put this on the Y position of where this is right now, where the collision block is supposed to be drawn. That is why we want the row index, so we can determine how far do we want to push down this collision block from the very top of where we start drawing things out. Now we also want the column index to determine how far from the left should we be pushing this collision block outwards. So right now, since we're on a column index of 0, we don't want to push it out at all. This value for x is going to remain 0. But as we continue looping through both of these arrays, let's say we get over to the third column. If we multiply 3 by 16, we're saying move over by about 48 pixels, and that's going to push this block over here. So every time we hit 202, we're going to be drawing blocks in their exact locations based off of the indices associated with our map. That is exactly why we're looping through everything using a 2D array, so we can easily grab those column and rows indices. So let's begin using those to begin placing our blocks. We know when we loop through each row, that is going to be the Y location of a block. So right here, I'm going to add a comma and add in an argument that says Y. This is really just the index we're currently looping over within this for each, but it makes sense to call this the Y value because it references our Y index. And right here, when we loop through each row, this is going to be our column index. You can either call it C, but I think it makes more sense to call this X because I like viewing this as we're using these indices based on the X and Y values in which we want to push our collision block to. So we're going to use these indices. This Y is going to be the row index. We can use that row index down here to place our collision block. I want to say place our collision block on the Y-axis by the current index we're looping over, times 16 because that is the size of our collision block. That's going to make sure that it's placed in the exact location, which we're currently looping over, where the symbol is equal to 202. Now let's do the same thing for X. Whenever we hit a 202, we want to find the column index, which is indicated by X, and then multiply that by 16 to make sure that we're moving this collision block to the correct location on the X-axis. So to see if we did this correctly, we can start by logging out our collision blocks array. We should see some collision blocks inside of here with different positions. Let's save, refresh. We definitely have 38 collision blocks, which is great. And we want to check their positions. So let's open the first one. That seems to be in the correct location. Remember I said we're going 23 indices down and 0 to the right. This seems to match up perfectly with the X and Y coordinates. Let's open up the next one. And that one definitely moved over 1 to the right. Perfect. We're looking to be in great shape. This one moved 2 over to the right. This is definitely working. So now all we need to do is render these out onto our map. To render these out, we're going to render these out the same way that we're rendering out our background and our actual players. We just need to go down to our animation loop right here, determine where do we want these rendered out relative to everything else. I think it makes sense to render this out right after our background. So let's render these by selecting our collision blocks and then calling for each on top of this and say for each collision block within this array, what do I want it to do? I want it to select that collision block object and then run update on it, which in return is going to render it out onto the screen. So let's save that. Refresh and see how things look. Okay, so things seem to be in the correct shape, but they're definitely not in the right location. Why is that? Well, we currently call this outside of our scale function right here. Everything within save and restore is currently scaling and translating stuff to the correct location. So you'll see if I take this collision block statement and place it within save and restore right here, which is also responsible for scale and translate, save and refresh, now these are immediately in the correct spot. And you can see this even better if I comment out scale and translate. Save and refresh. Now we have the small version of our map that was there before we scaled anything up. These are perfectly laid out, and this is the one-to-one representation in which I was mentioning that we have over here in tiled. So this obviously matches up quite well with what we have over here in our game. But we do want to make sure that it's scaled up because when we start panning things around, well, we need to make sure this background is much bigger than it is right now. That's the whole reason we're using the scale and translate function from the last lesson. So let's save that with collision blocks inside of it. Refresh, and now things are looking back to normal. So that is great, but we're not done just yet. Why is that? Well, if we look over within tiled, yes, we have our floor collisions, but what else do we have? We have our platform collisions. We need to make sure that we render these out as well, so we can start coding collision detection with them later on too. We want to make sure that we can jump on top of these platforms. So I want you to pause the video and see if you can render these out all on your own using the steps that we used to render out the floor collisions. It'll definitely be a challenge, but I think it'll be a good one to make sure that you really memorize these topics at hand. Otherwise, let's continue doing it together. So I want to export these platform collisions and import them into our game. Now I know I already exported everything that we see right here within its own map file. And we can check that by going over to our Finder and opening up vertical platformer map.js. Now I want the layer called platform collisions, so I can do a Command F for platform collisions. And if I scroll up, this is going to be all the data associated with those platform collisions. So I'll grab the array that contains all this data, copy it with Command C, and now I can import this into our game. I'll go back to our game over here, go inside of our data folder, and select collisions.js. So now I want to create a new array to store all this data. And to create a new array, I'll simply create a const down below called platform collisions. And I'm going to set this equal to that new array, which I just grabbed from over in tiled. So obviously we have 202s in different locations. That's great because we know we want to place these in locations that are definitely different from our floor collisions in the last array. So we already imported this file collisions.js into index.html, which means we can begin using it within index.js. So scrolling up to the top, we want to parse this into a 2D array so we can begin looping through it and placing collision blocks in their exact locations. So I'm going to duplicate what we have right here, starting with our const and going all the way to the bottom of our for loop. I'll copy that, and right beneath our collisions2d for each, I'll paste in the code I just copied. Now I don't want to create an array for floor collisions anymore, I want to create one for platform collisions2d instead, which means now I want to loop through our platform collisions, like so. And the amount we iterate through doesn't change, we don't have to change anything right here, but we do want to push in to our platform collisions 2D array rather than our floor collisions 2D array. So we'll change that to platform collisions 2D, and then we want to reference not our floor collisions, but our platform collisions. We're going to be slicing out data from there and placing it within this new platform collisions 2D array. So let's console log that out, platform collisions 2D, and I'll get rid of any other console logs because I don't really need them and they muddy up our code and our console. Let's save and refresh. And yeah, that is looking quite nice. All those platforms seem to be placed in their correct position. So now that I have this parsed out into a 2D array, I want to loop through it similar to like we did up above for our collision blocks. I'm going to grab everything right here and paste it down below our new for loop. Now I'm not going to call these collision blocks because I do want these to be different from the collision blocks because we're going to code them differently later on. So instead of referencing this as collision blocks, I'll call this platform collision blocks instead. And now we just need to change this code up to reference our new 2D array rather than the old one. So we're no longer referencing floor collisions. We're referencing platform collisions instead. We're still going to be looping through each row. We're still going to be looping through each symbol. All of that is fine. And the symbol is also equal to 202. That's totally okay because we're pushing into a new array for new functionality. Now I want to push in to our platform collision blocks, so we make sure that we separate everything, rather than pushing into our collision blocks array. So I'll replace that like so, and then we are pushing in a new collision block. We can leave this as is. But the last thing we need to do is just render all this out using our platform collision blocks. How do we do that? Well, we just scroll on down to our animation loop, and then within our little scale container here, I want to copy where we're looping through our collision blocks, and then loop through our platform collision blocks instead. And then I'll say for each block, I want to update and make sure that it's drawn out in its exact location. And as long as I've done this, I can save, refresh, and you can kind of see the beginning of a platform collision block up here. You can definitely see it right here, but what if I want to test out that everything is drawn in their correct location? I can simply comment out the scale and translate, refresh, and those are definitely drawn in their correct locations. We just saved ourselves a ton of time by not having to draw these out manually, painstakingly by the way, by figuring out these exact locations of the platforms and putting the collision blocks right on top of them one by one. That would be really annoying, so this is a great way to do it using tiled. Let's uncomment these two lines right there. Make sure things still look the same when we zoom in. It looks great right now. But that's pretty much how it's going to be done when it comes to rendering out platform and collision blocks. So let's go back to our to-do list and check off collision blocks. So now it is time to code collision detection. As we jump with our player, or players for this matter, we want to make sure that we are stopped by these collision blocks that we just put inside of our game. So how do we begin programming that? Well, let's go over to index.js. The first thing I'm going to do actually is get rid of player 2 just so we can have one sole focus on the player we're currently interacting with. So let's go ahead and take player 2 right here. It's on line 60 for me. Delete it, and then also delete the render function for player 2, which is on line 98. Delete that. Save and refresh, and player 2 is now gone. How sad. Now another thing I want to do is move player 1 over here on refresh, just so we can really test the falling and make sure that we're falling on top of these collision blocks over here. I just really want to center things out a bit. So to move our player over to the right, we're going to find where we're creating a new player, right here, and then we're going to change the x coordinate to something like 500, save and refresh, and we seem to be in good shape with that. Now the way this is going to work is I want to take all of our collision blocks and pass them through into our player class right here. And once I pass those into our player class, I can begin to monitor for collision between all of the blocks and our one singular player. So how would I start passing in those blocks into our player class? Well, wherever I instantiate a player, it's going to be right here on line 56 where we left off. I also want to push through all the collision blocks that we made for our floor collisions. How would I go about doing that? Well, you can see right here when we create a new player, right now we're only pushing in a position and it's not labeled. We don't actually know what x and y are. We kind of have to assume that these are positioned because there's just an x and y coordinate. It would be a lot better if we did that other technique where we have a label right here when passing through arguments through a constructor. So let's go and change that. Over in player.js, instead of just passing through position directly right here, I'm going to pass position through as a property within an object. And this is going to allow me to add a label over here within index.js to specify what x and y are. So within this object right here, I can say we have a position property, and that's going to be equal to an object with these x and y coordinates. So it's a lot more clear what we're passing through right here when creating a new player. Now the other thing I wanted to pass through is going to be those collision blocks I was mentioning. So we can add in a property to this object that says we are passing through collision blocks, and this property is going to be set equal to collision blocks. This is the array full of collision blocks, which we created up above. It's going to be right here. We pushed in all those collision blocks into our collision blocks array. So now we're going to pass it through into our new player constructor. And one cool thing is, if the name for the property right here is the exact same as the assignment, we can get rid of the assignment and the colon, and this right here is the exact same thing as this. It's just shorthand syntax to clean up our code a little bit. So we'll go with the shorthand syntax, and now that we're passing this through as a constructor argument, over in player.js, we need to make sure that we're adding this in to our constructor. We're specifying we're passing through our collision blocks like so. So once we pass through these collision blocks, the next thing we can do is assign these to an actual collision blocks property within our player class. So let's create that property with this dot collision blocks set equal to the collision blocks we're actually passing through. So now that they're passed through into the player class, we can begin to monitor for collision. Now, as we monitor for collision, we're going to need our player's position, and we're also going to need the player's width and the height. And you might notice right here, all we have available to us in regards to dimensions of our player is height. We do not have width available to us because we hard-coded a width right here with a value of 100. So we want to change this to a property of this dot width, and if we're using a property right here, we need to make sure that we declare the property within our constructor. So we'll say this dot width is also going to be equal to 100 to create that perfect square. And now with an update, we can begin coding that collision detection. So one thing I'm going to do is I'm going to get rid of these conditionals that we wrote to stop our player from falling past the bottom of our canvas. because now what's going to stop our player are those collision blocks instead. So really, we don't need this if statement right here, and we don't need this else statement. We're just going to let our player fall to start. But what we can do to make our code a bit more clear is we can add in a method called apply gravity. And then inside of this method, I'm going to take where we edit our y position, and when we add on to our y velocity with gravity, I'm going to take these two lines, paste them within apply gravity, like so. And now when I call update, instead of trying to understand what these two lines do, I can simply call this dot apply gravity to really understand what is going on here. We're going to add on to our x position, and then we're going to apply gravity to pull our player down towards the ground. So that's definitely a lot more understandable. But right after we pull down our player, I want to start detecting for vertical collision. We're going to start with vertical collision, and then we'll monitor for horizontal collision because we need to detect for collision on both sides to determine when our player should stop in both of those directions. So right after we apply gravity, we're going to do what? We're going to call this dot check for vertical collisions. This is going to be a class method, which we have yet to create. So let's create that method down below. Right under apply gravity, we're going to check for vertical collisions, and it's going to look like this. So what we want to do is begin looping through all of our collision blocks, and we can do that with for let I equal to 0. Our index is going to start at 0 for this for loop. As long as I is less than this, dot collision blocks dot length, so all the collision blocks in which we want to loop through, then we're going to add 1 onto I, that is our iterator. We're basically just looping through all of our collision blocks. And as long as we set up our for loop like this, what we can do is grab one singular collision block to detect for collision with. So I'll add a const here that says this one singular collision block in which we're selecting is going to be equal to this dot collision blocks. So all the collision blocks within our class. And then I want to select just one collision block by using our index, the current index we're looping with. So we can grab that one collision block, and it looks like I spelled this wrong, so I'll fix that real quick. And now we have that collision block. So I'm going to write an if statement that says, if this one collision block right here is colliding with our player on the y-axis, then we want to stop our player and move them to a specific position. How do we begin detecting for a collision between two rectangular objects? Well, here is how we're going to do it. I'm going to use this blue rectangle down here to represent one collision block, and then I'll draw this red rectangle up above to represent our player down here. So the first thing we need to do to detect for a collision is see, does the bottom of our player right here intersect with the top of our collision block? If so, we know the two are colliding where the bottom of the player touches the top of the collision block. We need to code that in. So the first thing we need to do is get to the bottom of the player. What is that value that represents the bottom of our player? Let's go ahead and get that. We can get the bottom of our player by referencing this dot position dot y. That's actually going to give us the top, but to get that bottom, we can add on to this dot height, and that is going to give us the value for the bottom of our player. So we want to say if this value right here is greater than or equal to the top of our collision block. How do we get the top of our collision block? All we need to do is reference the collision block we're currently looping over, and then grab its position on the y-axis. That's going to give us the top. So if the bottom of our player is greater than the top of our collision block, we know they're colliding from that angle. But we need to make sure that we're doing this for every side of our player to make sure that we're not doubling up on collisions, because this might be true for any other collision block. We want to make sure that we're definitely touching just one singular collision block and nothing else. So we want to add on an and statement and then test whether or not the top of the player is touching the bottom of a collision block. Let's look at this over here. So if I move our player down here and they're trying to jump up, we want to make sure the collision block stops them from jumping past this point. So we want to monitor for the top of our player and see if it intersects with the bottom of our collision block. Let's code that in. So we have an and statement, and I'm going to write if the top of our player, which I can get with this dot position dot y, is less than or equal to our collision block dot position dot y plus our collision block dot height. We know the two are intersecting from that direction. Now we need to do the same thing for the x-axis as well. So let's imagine that we have our player right here, and our collision block is actually going to be over here on the left. So if our player is coming in towards the left right here, what do we need to write? Well, we need to get the left side of our player and see, is this value less than or equal to the right side of this collision block? Let's write that out. So I'm going to add in an and statement and then get the left side of our player. I can get that by referencing this .position.x and say if this is less than or equal to the right side of our collision block, which now I can get with collision block.position.x plus our collision block.width. We know the two are intersecting from that direction. We only have one direction left, and that is if our player is going into a collision block from the right side of the player. Now, how would I write that? Well, we want to get the right side of the player. I'll add in an and statement. And to get that right side, I'll say this .position.x plus this .width. If the right side of our player is greater than or equal to the left side of our collision block, which I can now get with collision block position.x, we know the two are colliding there. So this is how we write pure collision detection between two rectangles. This is always going to work, but we're not done just yet. As you can see, this if statement is kind of beefy, and we are going to be using collision detection later on for other functions. So in this case, it makes sense to refactor this into a collision function to make our code more readable. So what I'm going to do is I'm going to cut out these 4 and statements, which I just wrote with Command X, and I'm going to create a new file. So go to File, New File, and then inside of this new file, I want to create a function called collision. And then I want to save this as a JavaScript file just so I can get syntax highlighting right off the bat. I'll hit Command S and save this as utils.js. Any utility functions that I'm writing, such as this collision function I'm about to write, are going to go inside of this utility.js file. Where do I want to save this? Well, within our JS folder. This is just a standard JS file, so it makes sense to go in here, hit save, and now we have that syntax highlighting. So let's continue writing this. Our function of collision is going to return parentheses, which basically compute this condition right here. If everything within this condition is true, we're going to return true. If not, we're going to return false. Now we do need to pass through 2 arguments, and I'm going to pass these through as one singular object with 2 properties. The first property is going to be object1. That's going to represent our player, and then second property is going to be object2. That is going to represent the collision block we're currently looping over. And since we're writing things like this, any place in which we have this dot, I want to select all of those instances. So 1, 2, 3, 4, 5, 6, and replace it with object1. And then same thing goes for our collision block. I want to select all those instances, 1, 2, 3, 4, 5, 6, and replace that with object2 instead. So this is how we're going to write a collision function. And this is going to make our code much cleaner when we use this within player.js. But if we want to use this within player.js, we need to make sure this is pulled in to our actual game. And to pull this into our game, we're going to go to index.html, create a new script tag, and we need to reference utils.js from our JS folder. Let's save this, and now we should be able to use this collision function directly within player.js. So within this if statement, now I can write if there is a collision, and I put in an empty object here, which we're now going to fill up with 2 properties. The first one is going to be object1. Object1 should be this, because that represents the player we're about to detect for a collision with. And then object2 is going to reference the collision block we're currently looping over. So this is much more readable. If there is a collision between this object and our collision block, then we're going to log out some code saying we are colliding. So we should be able to see this logged out once our player passes through those collision blocks within our game. So make sure you save that, inspect your element, open up your console, and let's refresh. So we fall through, and you can see that only happened 30 times for the exact period in which our player was touching these blocks over here. Let's see it again. Refresh, and you can see that only fills up as soon as our player is actually touching the blocks. So we know our collision detection is working correctly, but now we need to make our player react to this collision detection. And we can do that by saying within this collision right here, we know they're colliding, so we'll add in an additional conditional that says if this .velocity.y is greater than 0, meaning that we are currently falling down, then we immediately want to set this value of this .velocity.y equal to 0, which should get us stop moving as soon as the first collision is detected. Refresh, and we are definitely stopping right there, but there's an issue. Obviously, we're not touching our collision blocks. What's going on here? Well, remember, our background right here and the collision blocks are all being scaled, but one thing that's not being scaled is our player. So equations we're running this with are not completely exact because we're running our player at a different scale from the scale of our actual background and collision blocks. So we want to make sure over in index.js that we fix this within our animation loop by taking all of our player update code, and I'll also take our player input as well, and paste it within our c.save and c.restore section. So I'll paste that on in, save, refresh, and where did our player go? Well, it seems since we updated our scale, let's look at where we're assigning a position to our player. We're assigning an X position of 500. If we multiply that by 4, we're really moving that off to the right way far over in the distance. So let's reduce this to something like 100. And by reducing that scale, you can see now our player is back in the map. So we're basically reducing our map size, and by changing this position right here, we're making sure that our player is still viewable on the map, but now our player is way bigger than it was before. If we want to reduce this back to our original size, we can go over to player.js and divide this by a scale value of 4, or we can just do the equation directly and say that width and height should be equal to 25, and that'll shrink us down. Now we're falling down, but there's still another issue here. We're not falling on top of the collision block. So what's happening here? Well, let me draw out our player. We are falling down, and we are saying as soon as we detect a collision, which is going to be right about here because we're moving pretty fast at this moment, we're going to set our velocity equal to 0. So we set our velocity equal to 0, and now we're stuck in this exact location, but what we haven't done is move our player back up here. We detected for a collision, but all we did was say to stop moving once that collision detection happened. We need to make sure that we adjust the position of our player to move them to the exact location in which they should stop. So let's add that in. After we declare that our velocity on the y-axis should be equal to 0, we want to change this .position.y for our player to the very top of the collision block minus our player's height. So we'll set this equal to our collision block .position.y minus our player's height, which we can get with this .height. Let's save that and see how things look. Fresh, and now we are falling exactly on top of this collision block. Now, one thing I do want to note is, even though we are setting our player's position to this exact location, it might not look like we are colliding with a collision block, but we still are. If we want to make sure that we are not colliding for future instances, before we run some other code such as detecting for horizontal collision, we need to subtract a very small value from this, such as 0.01, and now we can run a horizontal collision check to make sure that we're not colliding with anything at all when we want to detect for a horizontal collision. You need to make sure that you have this in there when we're about to add horizontal collision, or else your collision detection code just isn't going to work properly. So make sure that you subtract 0.01 when you are falling down and trying to detect for a collision between the bottom of your player and the top of a collision block. Now this will work for the tops of the collision blocks, but we also want to monitor for collision with the bottoms of the collision blocks in case we insert those into our game. So after this if statement, I'm going to copy this and paste in a new one and say if we are moving upwards, meaning our velocity on the y-axis is less than 0, yes, we do want to set our y velocity back equal to 0, but we want to change our position to the bottom of our collision block. So we can get that with collision block.position.y plus the collision block's height. So instead of referencing this .height of our player, I'll say we want to get the current collision block's height, and then we want to add on this small buffer value right here of 0.01, and that's going to make sure that we can't pass any collision blocks placed on top of our player. And that's all we have to do to check for vertical collisions. As you can see, I can move around, I can jump really, really high, and then I can even go on top of these blocks over here. All I have to do is press to the left, and that vertical collision is going to take effect. Now we have vertical collision in place, but what I want to do before we apply any additional gravity is check for horizontal collisions to stop me from going past this wall right here or going on top of it. So that's the very next thing we have to do is check for those horizontal collisions. And the easiest way to do this is simply copy this check for vertical collisions method we just wrote. So I'm going to copy that, and I want to run this right before we apply our gravity. So in this case, I'm going to place our method right above apply gravity so I can remember the order in which this is supposed to run. I'm going to change check for vertical collisions to check for horizontal collisions. And now we're just going to do the same thing, but on the x-axis. So we're going to loop through our collision blocks. We can leave this the exact same. Detect for a collision between our player and the current collision block we're looping over. And then what do I want to do? I want to check whether or not we're moving left or to the right. So for velocity right here, we're no longer referencing y, but rather x. This means if we are moving to the right and we collide with a collision block to the right of us, what happens? Well, we want to set our velocity on the x-axis equal to 0, and then we want to change our x position to what? Well, our collision block's position on the x-axis minus our player's width. It's going to make sure that our player cannot move past any collision blocks to the right of us. We even have our little buffer right here That is perfect. We want to make sure that we are subtracting this, and that takes care of collision blocks on the right of us. But now right here, when we're moving to the left, meaning our y velocity is less than 0, we need to make sure that we take that collision detection into account. So we want to set our x velocity equal to 0. We're changing y right here to 0 as well. And then our position on the x-axis is going to be equal to our collision blocks, x position, plus that one collision block's width, plus 0.01, and that's going to stop us from moving past that collision block on the left of us. But we do need to make sure that we're running this directly within update, and it's very important that we run this right before this .apply gravity. So I'll put that in there. This check for horizontal collisions, because if we apply the gravity before we check this, well, we're going to be colliding with these collision blocks on the bottom of us for sure, because we just pulled our player down to detect for a collision right there. But if there is collision on the y-axis, you can see down here, we're setting our velocity y equal to 0. We're moving our player back up so they're not actually colliding. And then we're checking for our horizontal collisions, making sure that this collision detection code works as expected. So let's save, refresh, and now check for horizontal collisions. I can move to the left. And you can see I just can't get past that wall over here. We're no longer being moved up or anything like that. And if we want to clean up our code just a little bit, within these if statements, we can break out of a for loop if we're colliding with anything. Depending on which direction we're going, it's just going to make sure that we don't run the rest of this for loop right here. So we can do that in 4 locations, 2 up above when we're checking for horizontal collisions, and 2 right here when we're checking for vertical collisions. So if our velocity is greater than 0, meaning we're falling down, we detect for a collision, we break out of the for loop altogether. Same thing if we're hitting the bottom of a collision block. I just want to break out of this, and that's just going to speed up our code a little bit. We can't really even tell. But I do like the way this is looking. We have collision detection for our floor platforms, but our player is jumping quite high. Let's just fix that real quick. We know that is taking place within index.js, specifically right here when we hit key down and we press a W key. I'm going to change this to -10. That's just going really high up because we changed our scale, and I might even want to change that to a little lower, such as 8. And I like the way that it's looking. It's going to allow me to jump up over here and then eventually on top of these platforms when we add in our platform collision detection. So that is how we're going to add collision detection between our player and the floor platforms. Let's go back to to-do and check off collision detection. So now we're going to cover sprite animation. Obviously we have our player right here, but it would be a lot cooler if our player wasn't a red square. We're going to transform our red square into an actual player sprite, and in this case it's going to be a warrior. So to get this warrior asset, go ahead and check out the Google Drive link. There's going to be a folder within here called warrior. We go inside here and we have all these different states in which our warrior is going to be in, such as attack, death, fall, idle, etc. These sprites were made by an artist named Louis Mello. He's an incredible artist, and I really recommend checking out his page, following him, and donating to him. But these are what we're going to download. They're completely free, and we can use them on commercial projects like this. So to download this from the Google Drive link, I'm going to right-click, hit download, and that's going to start my download down here. So as you can see, that just downloaded. Now I can open this up within my Finder window, and here it is. So if I look at these really closely, we can see we have a sprite for attacks. We have a sprite for death, sprite for fall, all these different states in which we might need for our game. So really great work by Louis over there. We want to go ahead and copy these into our game folder. So I'm going to select all of these, hit Command C, and then go inside of web and find our game. It's going to be vertical platformer. And then inside of our image folder, I want to right click, create a new folder called warrior, and then paste in all those warrior sprites. So now that we have these available to us within our game over here, you can see we have that folder. We can begin using them to replace our player. So let's begin by doing that. So to do that, I want our player class to extend our sprite class, because I know when we wrote our sprite class over here, that we added in an image and it was meant to draw out that image. And I want our player to have that same functionality, and using inheritance is a really good way to just grab this functionality really quickly. So let's go ahead and do that. Over in player.js, I want to extend our player class. So let's say class player extends what? Well, our sprite class. And once we do this, we're going to get access to all these properties that are written right here within our sprite constructor. But one thing is, if we want to pass through an image source, with our player class over here, we need to make sure that we specify within our constructor that we're passing through an image source, and then we're going to call something called super. And what super does is it calls the constructor of whatever parent class we're using, which in this case is going to be our sprite class. So we call super, we go over Sprite.js, we call this constructor, we set all these properties, and then we go through the rest of our player constructor and call the rest of this code. So if we want to call our parent constructor within Sprite, we need to pass through properties as specified within our constructor over here. And we know that takes an image source. So I'll say that our image source is going to be passed through to the parent constructor from our player constructor. And now we should be able to begin using this image source directly within our player class when we instantiate it. So let's add that in. Over in index.js, let's find where we're creating our player. Right now it's on line 56 for me. I want to add in a new property called image source and specify what source should we be using to create our new player sprite. Well, I want to go inside of our image folder in this case, because we're starting out at index.js, and then I want to go inside of our warrior folder, and then reference idle.png, because this just means we're standing in a singular location. So I'll say I'm referencing idle.png right here. Let's save, refresh, and see if anything happens. And no, everything looks exactly the same. Why is that though? Well, let's look at our player class. And as you can see, we have a draw method right here which specifies how our player is being drawn out. But if we also look within Sprite.js, we have a draw class right here, which says our sprite should be drawn out using c.drawImage. But the names are the same. We have a draw method right here within Sprite.js and a draw method over here within Player.js. If that's the case, the child method is going to overwrite the parent method. So right now we're calling this code right here within our child class, and not the code we want to call within our parent class. So all we need to do to fix this is get rid of this draw method right here. We're no longer going to draw out a simple rectangle for our player. I'll delete that, and just by deleting it, now whenever we call player.draw within our update method, right here, we're calling the parent's draw method. So we're going to call c.drawImage on whatever image we are passing through using image source. Let's save and refresh, and you can see our player is falling with that new sprite, but is falling past the boundaries of our collision blocks. Let's go ahead and fix that next, now that we actually have this image imported into our game. So the reason our player is falling through is because we're using an image with a different width and height compared to that little red rectangle that we were using earlier to detect for collision between our player and our collision blocks. Let's look at player.js. If we look closely, we're using a width of 25 and a height of 25, but really, our image over here is much bigger than 25 pixels, so we need to use the width and height associated with this image for collision detection, not this static width and height of just 25, which we declared earlier. So we're going to get rid of these two lines, and we're going to declare a width and height directly within sprite.js. So I want width and height to be declared based off of our image's width and height. And to do that, I'm going to monitor for when our image actually loads. So I'm going to say if this image on load, what are we going to do? We're going to call the following arrow function on load. And now inside of this, we can declare that we want the main width associated with the sprite to be equal to the image's width, which we can get with this .image.width. We need to make sure that we call this within this onload method right here, because if we don't, we're going to try to set this .width equal to this .image width, and this isn't going to be available to us immediately because an image takes time to load. We need to make sure that it fully loads before this will be available to us so that we can set this .width. We also want to set our height, so I'm going to duplicate this line, replace width with height in both locations, and now our width and height over in player.js should be set correctly because we're referencing the width and height associated with our images. Let's save and refresh and see how things look. And now you can see that collision detection is pretty on point. Yes, our feet are not touching the collision blocks, but that's totally okay because that's just the way our image is laid out at the moment, and we're going to fix this. But to see exactly how large our image is right now, let's add in a background overlay. I'm going to do this directly within player.js right before we call this .draw. And I just want to draw out a rectangle that's transparent to see the full width and height of this image that we're working with. It's going to give us a little bit of clarity of what's going on here with our player not touching the ground. So to add in that rectangle, I'm going to call c.fillRect. Simple enough. And I know this takes an x and a y position. So x will be this .position.x, y will be this .position.y, and then a width and a height. And I want to use the width and the height that's generated over in Sprite.js. And now all I need to do is declare a color for this rectangle. So right above, I'll say c.fillStyle will be equal to RGBA, so we can use transparent values. And I don't want this to be equal to red because I want this to contrast with our red collision blocks. So I'll say red is going to be equal to 0. We're going to use the high range right here for blue. Say that's 255, and then for green, I want that to be equal to 0. This is going to be a blue block. And then finally, for our transparency, I want that equal to about 0.2 so we can really see through it. But with this, we save and refresh. And now we can see I actually set the green value, that's totally okay. But now we can visualize the full width and height of this image. You'll see when our image touches the collision block over here, we can no longer go past that value. And as I move to the left, you can see we have all these different frames which represent the idle state. We're basically going to be looping through these frames to create an animation. I'm going to explain that very shortly. But that is going to be the next step here, is we want to crop this image and then start looping through all the different frames of this image to create an animation. Let's illustrate it. Right now we have idle PNG selected. We have 8 different images of our player in an idle state. We can count them. 1, 2, 3, 4, 5, 6, 7, 8. From far away, they might not look that different, but when we zoom in, there's going to be very subtle movements which are going to create off an effect as if our player is moving in a standing position. So what we need to do in the code is basically crop a specific section of the sprite sheet. And we're going to start by cropping from the top left-hand corner of the image. We're going to extend all the way to somewhere like right here, and when we crop out this one section, nothing else over here is going to be available to us. We're just going to see whatever is inside of this red rectangle. But what we're going to do is adjust the position of this crop box. We're going to adjust it slightly so that it moves over perfectly to the very next frame of our sprite sheet. And then once we're here, what are we going to do? We're going to move it over to the next position. We're just going to keep affecting the X value of this crop box through this whole sprite sheet until we reach the very end. And once we reach the very end, what are we going to do? We're going to go back to the very beginning, and we're just going to loop through this whole process over and over and over again to create the illusion of animation. So that's how animation works with sprite sheets, is we crop a specific portion and we move the crop box so that we loop through all the different states in which our player might be in using the sprite sheet. So we're going to code that out directly within sprite.js. Let's head over there now. So we want to begin adding some sort of crop box to begin cropping our image, and we're going to do that within our draw method. So let's begin creating that crop box. I'll start by creating a const called crop box and set this equal to an object with a position property. And that's going to have an X and a Y coordinate. So X will be equal to 0 to start, Y will be equal to 0. And then it's also going to have a width. I'll set that equal to 0 too. And then a height. We're just laying out the beginning of this crop box. Now, if I want to begin using this crop box to actually crop our image which we're rendering out, we need to edit the draw image method a little bit. And this is a little bit confusing. I'm not really a big fan of the API for this because basically what we need to do is add in 6 separate arguments to get this working. And we need to add in crop box arguments in between what we have right now. It doesn't really make sense. But once we have about 9 arguments in this function, then things are going to work with the crop box. It'll make more sense as we do it, but I should just give that disclaimer. Doesn't make much sense API-wise. So for the crop box, right after this .image, I'm going to add in an argument right here that specifies the crop box's position on the x-axis. So I'll say the x position is going to be cropbox.position.x. Right after this, we need a third argument. This is going to be the crop box position on the y-axis. So we'll get that with cropbox.position.y. Can you guess the fourth one? It's going to be the crop box's width. So here we'll put cropbox.width. I'll save the auto format this, and then we have a fifth argument right after crop box width. It's going to be our crop box height. And that's what we need to get started. So really, to get this whole crop box effect working, we do need to add in 2 more arguments after position X and position Y, which is going to be the actual position of our image on the screen. We need to add in the actual width of the image, which we're about to render out, and then the actual height of the image, which we're about to render out. So this is what a successful cropping looks like using c.drawImage. A little messy, but we're going to go through this whole thing step by step. So these 4 arguments right here represent the crop box. If we go back to idle.png, the crop box is just this red rectangle. We need to define its position and its width and its height. Right now, its position is what? 0, 0. We can leave that as is. We're going to edit it later on. But we do need to determine the width and height of this crop box. How do we determine that? Well, it looks like our height is constant across this whole image. We don't need to do anything for our height, but if we want to crop down our whole image, which currently has a width of this wide, we need to basically divide this by however many frames are within our sprite sheet. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. If we divide the full width of our image by 8, the frame rate, we are going to get the width of this one crop box location right here in which we want to crop our image down to. That's how it's going to work. However many images we have within the sprite sheet, we're going to use that to divide the width by, and that's going to give us the crop box width. Let's do that within sprite.js. So width right now is equal to 0. Let's change this. This should actually be equal to this dot image dot width. So the full width of the image divided by our frame rate. In this case, that frame rate is 8. But remember, we have other objects using the sprite class, mainly our background image. If I were to save this and then refresh, you can see everything just turns white. We're not rendering out our player, we're not rendering our background sprite, because our background sprite does not have a frame rate of 8. It completely ruins everything when we do this, and I guess also we haven't set our height property. Let's just set our height property real quick to this .image.height, save, refresh, and things still look pretty bad, but obviously the width is just way off for that issue I was mentioning earlier. We're dividing this by 8, even for an image that only has one frame in it, that being our background image. So this value right here actually needs to be dynamic based on the sprite's frame rate. And what that means is we need to add in a property called this.framerate to make sure that this is different across all of our sprites. So frame rate is going to be equal to a frame rate in which we pass through a sprite constructor. I'll pass that through right here by saying our frame rate by default is always going to be equal to 1. This means if we only have one singular frame within a sprite image, we don't actually have to pass through a frame rate value. But we do want to make sure that this changes for when we create a player, and if we want to pass this through our player class as well, we need to take this frame rate argument, go into player.js, and then pass it through this constructor as well. So when we create a new player, we'll pass through a frame rate, and then pass that off to our sprite parent, which in return is going to set this .framerate, and then we're going to use that down here instead of 8. So we'll replace 8 with this .framerate. If we save that, that should fix the background image, and it does. But that doesn't really fix things right here for our warrior because the frame rate is still 1. We're still rendering out the full image as you can see. And that is simply because over in index.js, we never actually passed through that new frame rate value, which specifies we have 8 frames for our player class. So when we're creating a player, we want to specify that frame rate is going to be 8 because we counted how many frames were within idle PNG. So let's save that, refresh, and things are definitely off here. We don't see our player at all. So let's do a little bit of analysis. We'll go to sprite.js, and right here actually, for this 8th argument within c.drawImage, we have this .width. We also want to make sure that we're dividing this by the current frame rate as well, because otherwise what we're doing is basically just really stretching out our image. We want to make sure that we're only rendering out the same width in which we're declaring for our crop box. We don't want to stretch or shrink anything. So let's save that, refresh, and there is our player. But things still kind of look the same, I guess, but if we start moving to the left, you're going to notice that the rest of our frames are not showing at all. And that is a great start. That's exactly what we want. But it is a little confusing because this green rectangle, which is supposed to represent the full width of our image, is just taking up that full original width. Let's fix that by going up here to our onload method and dividing this .image_width by this .framerate. And if we do that, the width in which we're using to draw out our player over in player.js should only be the width of our actual cropping. So if we save that, refresh, everything is really shrunk over here, and that is simply because over in Sprite.js, now this .width is being divided by the frame rate twice, up here, as you can see, and also down here, so we're effectively shrinking it by another 8 frames. Let's get rid of that right here, save, refresh, and now things are looking much better. We can see that we're only cropping out this green area right here, and we're only showing that one portion of our actual image. Now we'll begin looping through these frames to create the illusion of animation. So going over the process right now, if we're to look at this right here, we are currently in this position. We need to start moving this crop box over until we get to the very end of our sprite sheet over here. How do we start moving the crop box position? Well, let's look at sprite.js. What we need to do is move this value of x, and as we move that, we're going to affect how c.drawImage works, and we're going to be pushing over that crop box to draw out the next frame within the sprite sheet. So what should 0 be to make it dynamic? It's going to be equal to the frame we are currently on, which is going to be dynamic. I'll declare that with this.current frame. And we want to multiply that by the current cropped width of the image. We can get that with this.image.width divided by this.framerate. And we should be good to go with that. We do need to declare this.current frame though. So up here within our constructor, I'll say that this.current frame is equal to 0 to start. That just means we are currently over here on the 0th frame, but we want to start increasing that frame to push us over by the exact amount of width of this crop box. That's basically what we just wrote down here. We just need to start increasing this.current frame over time. And since we have both an update method right here within Sprite.js and also player.js, I want to create a separate method responsible for updating our frames. So right beneath update right here within Sprite.js, I'll create a method called update frames like so. And then inside of this, I'm going to take this.current frame, the frame we're currently on, and add 1 onto it. So now what I can do is I can use this method within Sprite.js's update method right here. So after we draw, we're going to call update frames. That calls this code. And I can also call this within player.js's update method, which is definitely a lot different than what we have within Sprite.js. So the very first thing I'm going to do is call this.update frames. Let's save and refresh and see what happens. So we don't see anything at all. Why is that? Well, we are currently looping through this so fast, we don't actually see what is happening. When our current frame gets to the very end of our animation, we can see this within idle PNG. When we get to the very end, we want to loop back to the very beginning. So it's very important that we code that in, because right now we can't see anything happening at all over here within our actual game. So back within Sprite.js, as we update our frames, yes, we want to increase our current frame, but we only want to do this if current frame is less than our current frame rate. So we'll write an if statement that says if this.current frame is less than our frame rate, so this.frame rate, minus 0, because we need to take into account, let's say that our background sprite has a frame rate of 1. Yes, our current frame is going to start off on 0. That means this is equal to true, but we don't actually want to increase the current frame to a value of 1. Because if we do that for our background, we're effectively moving over that crop box to a location that does not exist. We're not going to render anything out if that is the case when we're using an image that just has 1 frame inside of it. So that is why right here we want to subtract a value of 1 from our frame rate within this conditional to determine whether or not we're adding 1 onto the current frame. But if that is not true, we're going to take this.current frame and set it back equal to 0. Let's see what this looks like. Let's save, refresh, and now everything just seems to magically work. Our background is back in place because we're no longer pushing it off to the side. We're not getting that white background anymore. And our player is just animating super quickly. But you can see those effects taking place because our crop box is moving across that whole sprite sheet, going back to the beginning. It's just a little fast for our liking. So what we want to do is slow this down using what I call a frame buffer. And to create that frame buffer, we're going to go inside of Sprite.js and say that this.frame buffer is equal to a value anywhere from, let's say, 2 to 10 to start. I'll say our frame buffer will be 3. Now to get this frame buffer effect working, I also want to add in a property called this.elapsed frames. This will be equal to 0, and this specifies how many frames have elapsed since the creation of this animated sprite. So every time we update a frame, I'm going to take this.elapsed frames and add 1 onto it. And now I can begin using this to determine how often I should actually call this code down here. I'll say if this.elapsed frames modulo this.frame buffer is equal to 0, then that is when we actually want to call this if and else statement down here. We're going to use that modulo to divide 0 by the frame buffer, which in this case is 3, and see if there is a remainder. In this case, there is not one. This is not equal to 0, so we don't actually run this code down below. But let's say that we increase elapsed frames. We go to the next iteration of this loop. Elapsed frames is going to be equal to 1. Let's divide that by the frame buffer. Is the remainder equal to 0? No, it is not. This is going to give us something like 0.33 for a remainder. That is not equal to 0 at all. But eventually, elapsed frames will be equal to 3. We divide that by our frame buffer down below. That's equal to 3. Is there a remainder in this case? No, there is no remainder. This will be equal to 0. Therefore, we're going to add 1 onto our current frame, but it's going to delay the process in which this happens. It's going to make it happen a lot slower than if we were to just run this right off the bat without this frame buffer in place. So let's save this, refresh, and see how it looks. So we're moving a lot slower in this instance, and we can change this frame buffer for each of our sprites. Let's say we wanted to add one in later. We basically make this frame buffer a dynamic value. So instead of referencing 3, I'll reference a frame buffer, which will pass through a sprite constructor. And up here, I'll say that our frame buffer by default is going to be equal to 3. And that should make things pretty good for now regarding how often our player is actually looping through that animation. So the last thing I would do for this lesson is scale our player down, because right now the image we're using for the sprite sheet is quite large. Our player doesn't really match up with what we have here in the background. So to scale down just our player, here's how we're going to do it. We're going to add in a sprite property to our sprite class. Right after this position, I'll say that this .scale is going to be whatever scale we pass through as an argument right here, because we don't want to scale our background down at all, not at the moment at least. So up here, I'll say that our scale by default is equal to 1 to make sure that we maintain that scale value, but we can always change it if needed. And I know I wanted to change this specifically within our player.js class, which means I also have to pass this through as an argument here, pass through a scale argument, and say that the default scale for our player is 0.5. Now I can pass that through to the parent constructor by adding it to our super method right here. And now we can begin using scale specifically for our player. Now, how would I affect the width and the height of the image using the scale value? Pretty simply, I would go in here where we're determining the width and height. I'm going to wrap this within parentheses to make sure that it occurs first, and then multiply it by this dot scale. And then I'll do the same thing for our height. We're multiplying this value right here for our width and height by a value of 0.5. It's definitely going to shrink the image, specifically for our player, because that is what we declared over here in player.js. So let's save and refresh, and you can see our player is much smaller using those scale values. So I really like the way this looks right now. The next thing we would want to do is add in a hitbox to make sure that our player's feet touch the ground and that we're only colliding with these collision blocks when it actually looks like our player is colliding with them. Obviously, we have all this space required for the sprite sheet to work and actually loop through the whole image, but we definitely want to make sure we're only colliding with the hitbox associated with our player. But for now, let's go back to our to-do list and check off sprite animation. So now we're going to code the hitbox implementation I was just talking about. We want our player's feet to touch the ground, and we want our player to collide with this little area which our player actually consists of, not the very left or far right hand side of the full sprite crop container. So how do we begin adding in this little hitbox container that we're going to use for our new collisions? Well, to do this, we're going to go over to player.js. And inside of here, I'm going to add in a property called this.hitbox. It'll be equal to an object that represents the dimensions and position of a rectangle, specifically the rectangle we're going to use for this hitbox collisions. So what is the position going to be for this to start? It's going to have an x of 0 and a y of 0. And then we're going to have a width and a height. And I'll just say that this is going to be equal to 10. We're just going to draw out a simple square for this hitbox, but we need to think to ourselves, if our hitbox has a position of 0, 0, and we render this out onto our canvas, 0 for both x and y represents the top left-hand corner of our canvas. We're not going to see this at all unless we specify. We actually want our x and y position equal to the position of our player. So for position x on our hitbox, I'll say x is actually equal to this .position.x. That refers to the x position of our player, which is always going to be moving based on our inputs. And then the y position is always going to be moving based on gravity. So I'll say our hitbox y is equal to this .position.y. Now this is only going to set once when we actually create our player because it's within our constructor. If we want this to update over time along with our player's position x and position y, we need to throw this code over in our update method right here. But if we do that, it definitely muddies up our code a little bit. It makes this whole thing a lot harder to read. So in this case, it makes sense to put this within its own separate method. This method I'm going to put this in is called update hitbox. And all we need to do in this case is paste in the same code that we have up here when declaring the property initially. So now within update, we can call right after this .update frames, this .update hitbox, like so. And now that's going to update accordingly. We're not going to see anything happen. All these variables are just going to update on their own in the background. But if we want to see what this hitbox looks like, we need to draw it out using a c.fillRect. So we know we already have that right here for our main image. I'll say this draws out the image. I want to draw this out for our hitbox as well. So right after we draw out the image rectangle, that's the green one, I want to draw out a red rectangle to represent our hitbox. And I'm going to do that by copying these two lines right here, pasting them down below, and then specifying I want a different color for this hitbox. Let's say I want to use red for this. I'll change this first value right here from 0 to 255, and then make sure I'm getting rid of this green 255 by replacing that with 0. And then I want to fill in a rectangle using our hitbox coordinates, not our player coordinates like we are right now. So I'll replace this .position x with this .hitbox position x. And I want to do this for all four arguments. So this .hitbox position y, this .hitbox.width, and then over here we have this .hitbox.height. It's going to look a little something like that. But as long as we've done this correctly, we can save, refresh, and now you can see our hitbox is being rendered out in the top left-hand corner. So what I want to do is move our hitbox to cover the area in which I want collisions to happen with our actual sprite. Now, doing this is just going to be trial and error, or at least that is the easiest way to get this moved from up here to a location over here, and that's exactly what we're going to do. But as you can see, as I refresh this to do the trial and error method, it's pretty annoying to have to test this when our player has to fall a few seconds down from the sky. So let's change our player's initial Y position so we don't have to go through that whole annoying process. And over here within index.js on line 59 for me, when I'm creating a new player, I'm going to change that Y position equal to 300 and move our player down the screen, and there we go. We can see this right off the bat exactly where it is. We don't have to wait or anything annoying like that. So let's start positioning this hitbox to be on top of our player. And to do that, it's going to happen within player.js. And I want to go to our update hitbox method. Basically, I'm going to start by moving the x position by a static value. Let's just say the static value is equal to 30 to start. Refresh that, and that looks to be pretty close to the left-hand side of our player. Let's increase this by 5, see what that looks like. Pretty good, I like how this is looking. Now let's move this hitbox down to be at the top of our player near his crown. I'm going to start by changing position Y to have 25 pixels added onto it. That's already pretty close. I might even stop it just there. Might have nailed it on that one. Maybe increase it by a pixel, go up to 26. And I think that is perfect. I'm not going to go past that. Now I need to change the hitbox's width and height, so it takes up the full width of our character and the full height down here. So for our width, we have 10, which is already pretty close, I think. Let's go up to 15. That might already be a little too much. Maybe we can shrink 1 pixel off of that. Go down to 14. And I like what that looks like for our width. Let's go over to our height. Let's double this and go up to 20. Pretty close to the bottom down there. We'll go up to, let's say, 27. Refresh, and yeah, that seems to be right at the feet. So now we're going to monitor for collisions between this hitbox we just created and all of our collision blocks rather than our main image, which is this green rectangle we have currently. And to do this, it's going to be really easy. We're going to find first our vertical collisions, which are going to happen down here. And as you can see, we're monitoring for collision using this collision function we created. We're no longer going to monitor for just this, which contains our player's dimensions. We're going to monitor between this .hitbox, which has a position, a width, and a height, which is used within this collision method in the first place. If we just do this, everything should work for monitoring for collisions between our hitbox and the collision block. Let's see what this looks like. Let's save and refresh. And yeah, that is pretty close. We're definitely going down towards our collision blocks, but we are jumping back up and falling back down immediately, creating this jitter effect. And that is because we are repositioning our player based off of our original height. You can see right here we're using this .height when we fall down to move our player back to a different position so that it looks like they're standing on top of the collision blocks. We now want this based off of the dimensions of our hitbox, but it's a little tricky because we need to move our player up by an exact amount. So over here, it's pretty annoying to have to look at this because things are just jittering up and down, but we do need to do a little bit of math and understanding here. So I'm going to do that over here within my code. So here's how this is going to work. We have our green container, which represents our image. And then obviously we have our hitbox container represented by this red rectangle. And then at the bottom, we're going to have our collision blocks right here. So what's happening currently is we're moving both our green rectangle and our red rectangle down. And we're only monitoring for collision when our red rectangle intersects with our collision blocks. So once we intersect right here, we monitor for a collision. That's where this is happening. right here with this collision detection. And then we are moving everything back up, but we're moving everything back up based on our main green rectangle. Those are the dimensions related to our main player image. And if that's the case, now we have a little bit of space in which our hitbox can fall. And since that little space exists, we start falling down, and then we repeat the process. We start colliding and we move back up to that position based on the green rectangle instead of the red hitbox. And that is exactly what's happening over here, causing the jittering, and only move our hitbox up by the correct amount. So rather than moving our hitbox all the way up here, when we collide with our ground, right here, we want to move our hitbox up by this exact amount so that it's placed perfectly on top of our collision blocks. So how do we move it up by this exact amount? Well, we need to find the distance between the bottom of our collision blocks right now to the very top of this green container in this exact position. How would we get that? Well, we know we can get the height of our hitbox right here easily because we already have that assigned. That just means we have to get the distance between the top of our hitbox and the top of our actual green rectangle. How would we do that? Well, simply enough, we'd get the position on the y-axis of our hitbox and subtract from that the y position of our main player. So to show you some math right here, let's just say that our y position of our hitbox is equal to 100, right? And then the y position up here of our green container is 50. Let's subtract 100 from 50. 100 minus 50. That is going to be equal to no other than 50. That is the exact value of this line right here, which means all we have to do is add on the height of our hitbox, and that's going to give us the full value of this blue line right here in which we need to move our hitbox up by. So let's start putting this math into action within our code. We know when we are colliding with a collision block and we're going down, based on this if statement right here, that we want to affect the position of that hitbox. We want to move it back upwards. And to do that, we're going to subtract what's known as an offset. So I'm going to create a constant called offset, and then I'm going to do that exact equation which we wrote up here. I'm going to start by getting the position of our hitbox on the y-axis. Let's do that. This dot hitbox dot position dot y. I have that, and now I want to subtract the position of our main player, the player image, and that's going to be represented by the green rectangle. And we can get that with this dot position dot y. And then we want to add on our hitbox height. So we'll do that right here by saying add on this dot hitbox dot height. Finally, right here, we want our position to be based off the top of our collision block. That's great. And then instead of subtracting our image height, we're going to subtract this offset we just calculated. So let's save that. And we refresh, and that is looking to be a lot closer, although there is a little bit of jitteriness still happening right here. So how do we fix this jitter? While scrolling up above, it's very important before we check for both vertical and horizontal collisions that we update this hitbox property right here, because we know its x and y position are going to be based off the position of that green rectangle, which represents this dot position x, and this dot position y. So we always want these values to be updated before we check for vertical and horizontal collisions, and to do that, all we need to do is grab this dot update hitbox and make sure that we paste it before those two methods. So let's save that, refresh, and now this seems to be perfect. We're not jittering at all. We're going to the exact position we want when colliding vertically with these hitboxes, but we still need to change things for if we were to collide with a hitbox up above, and for when we collide with hitboxes on the side of us. So let's do that now. When we're checking for vertical collisions, yes, we checked for hitboxes beneath us. We need to check for hitboxes above us. And to do that, yes, we're going to use an offset, but we're going to do this a little bit differently. I'll paste in that offset like so. And now in this case, the collision blocks are above us. So let's say that we're moving upwards. We collide right here. We want to make sure that we move our player down by this perfect amount so that we don't have any jitteriness and we don't transport our player back to a random position down beneath the collision blocks. So we already have the bottom of our collision blocks down here. When we add on collision block position y to collision block height, that is going to give us the bottom. That's exactly what we need to start. But we need to subtract from this the value between the top of our hitbox and the top of our player. So how do we get that? Well, the position of our player is just this dot position y, and the top of our hitbox is just this dot position y as well. So we need to get the value between those two, and we can get that really easily. We're just going to take this hitbox position y and subtract from it this dot position y. We already have this set up from when we were falling down, but we don't want to add on this dot hitbox height. We don't need that anymore. And once we have offset here, we can subtract from the bottom of our collision blocks the offset in which we just calculated, that little bit amount of space right here, to make sure that our player is placed in the exact perfect location for when the top of our player hits the bottom of a collision block. So we don't really have a way to test that at the moment because we don't have any vertical collision blocks, but this should work. Let me know in the comments if it doesn't and I'll try to provide a solution. Let's go ahead and add in collisions on the x-axis for a hitbox as well. So we're going to follow a very similar technique by using this offset const. I'll go ahead and grab one right here and go up to where we are checking for horizontal collisions. So right now we're still monitoring for this. This is the green rectangle that represents our full player image. We no longer want to use just this, but rather this dot hitbox. And now we refresh and we can move around freely, but when we hit a box over here, we're not transported to the correct location. So when our velocity is negative, we need to make sure that we move our player right about here to stop them from teleporting back over here. Let's focus on that first when our x velocity is negative. What I'm going to do is I'm going to paste in the offset which we used previously for our y, and now our collision blocks are on the left hand side here. So our main image is going to collide, but we're not going to monitor for collision until our hitbox collides with actual blocks. Right now we're moving our main green container all the way over here to the right hand side of our collision blocks, which means we also want to subtract from this equation the distance between these two right here. We need to find this distance and subtract it from the right side of our collision blocks. And we can get this very easily. We just need to get the greater value and subtract the lower value on the x-axis. So the greater value is going to be something like 100 right here for our hitbox, and then something like 50 right here for our main image box. So we'll grab our hitbox position on the x-axis and subtract from it our green box position on the x-axis as well. We don't need to do anything with our hitbox height or width for this. And now we have the right side of our collision block right here. We just need to subtract from this our offset to move our player to that perfect position. And we still have that little buffer right there to make sure that we're not continuously colliding with that side of the collision block. Save and refresh. And now that works pretty much just perfectly. Looking great. We want to do the same thing for the right side if there were collision blocks on the right though. So let's add that in. We have our offset right here. I'm going to copy that. And then as we're moving to the right, I'll paste in that offset. Now let's do a visualization over here as well. I'm going to move the collision blocks to the right. So here's what's happening currently, is we're moving our main image box over here, and then we collide with our hitbox. But right now, we are moving back based off of our main green box. What we want to do is take the left side of our collision blocks, and then we want to add onto it the space right here between our hitbox and our main image box. And now basically we want to do the same thing that we did for our y-axis. We can leave this exactly the same for our offset, but we want to add onto this hitbox.width. And that'll give us the exact amount we want to move by. So we'll take this offset right here, and then we'll subtract from our collision block position on the x-axis, not this .width, not the full width of the image, but just the perfect amount of spacing based off this offset to place our hitbox in the correct position. And once again, we don't really have any place to test this out on at the moment. But if there are things wrong with this, just let me know in the description of the video, and I'll be sure to help you out. But right now, that is how we're going to add in that little hitbox effect. So once we've completed this, we can head back over to To-Do and check off hitbox implementation. So now we're going to focus on sprite swapping. When we look at our game over here, we currently have one animation in place, and that is our idle animation. We're just bobbing up or down, but wouldn't it be cool if we added in a running animation, a jumping animation, or a falling animation? We're going to learn how to add all those in by doing what I call sprite swapping. So how does sprite swapping work? Well, if we look over in Sprite.js, we know that we have this image property. And this image property is used within c.drawImage. This right here determines which sprite sheet we are currently animating for our game. So if we were to swap out this current sprite, the idle sprite, with a different one such as a run sprite, we would need to swap out this .image with a new sprite image, specifically the running one. So I'm going to create a library of sprites in which we can easily swap in and out between, but to do that I need to add in a property over to player.js. So the property I'm going to add in is going to be this .animations, and this is going to be equal to an animations argument, which will pass through our constructor up here. So I'm going to add in that animations property and just make sure this is within player.js. But once that's added in, we need to pass through all of our animations. So over in index.js, right here where we're creating a player, for me this is on line 56, I want to start by declaring an animations property. This is going to be equal to an object with a bunch of objects inside of it. So these objects inside of it are going to declare which sprite sheets we want to use for our player. I'm going to start with the one we have currently, and it's going to be our idle sprite. So I'm going to create an idle property, and it's going to be equal to an object that has an image source and a frame rate property. Right here we have these for the default sprite. I wanted to add these for the default, but for this idle property. So I'll paste those two in, and that's going to complete the library section for our idle sprite. That's all we need to start. But we do want to swap between different sprites. What is the first sprite we're going to swap to? It's going to be our running sprite. And that is right here within our warrior folder. It is run.png when we're running over to the right. So we want to create a property for this. We're expanding our animation library for our player. I'm just going to duplicate this idle object we just created and declare instead of idle, I want to reference a run property. And this run property is going to have an image source equal to run.png instead of idle.png. And now we just need to count how many frames are within this run.png sprite. So we'll head on over to run.png and count them. We have 1, 2, 3, 4, 5, 6, 7, 8. Lucky yes, we don't need to change our frame rate over in index.js right here. So we can keep that as is. So we have these new animation objects, and obviously they're stored within this animations property. What we need to do next is make sure that we're creating a JavaScript image object and storing that within each of these objects right here. It's going to make more sense as we do it, so let's just start implementing it. Over in player.js, we have this .animations being declared, and we're obviously passing through those new animations we just added over in index.js. But I need to create a JavaScript image object, similar to what we did over in sprite.js. Right here, we declare a new image is equal to this image. I need to do the same thing for those other sprites we just created, because otherwise, this .image just wouldn't work. We need to make sure that this .image right here is a JavaScript image object. Otherwise, it won't work within c.drawImage. So we need to make sure that we're doing that within player.js. And to do this, for all the animations within the this.animations object, I'm going to loop through all those different keys, all those objects we just added in. Right now we have idle and we also have run. So to loop through those properties, I'm going to use a for loop that says for let key in this.animations. And what this is going to do is it's going to give us the key associated with each object within this.animations. So to illustrate this, it's going to give us the idle key to start, and then it's going to give us the run key because we're just looping through whatever objects are directly within the animations object right here. That's all we need to do to start. But what we're going to do next is within this for loop, create a new image object. So const image is equal to a new JavaScript image object. So for each key, such as idle or run, we're going to be creating this new JavaScript image object, and we need to set the image.src associated with that object equal to the source of the animation we're currently looping over. So to get a specific animation source, such as idle.image source, here's how we're going to do it. We're going to reference our main animations object, which we can get with this .animations. And then we want to get the one individual object in which we want to reference image source. And we can get that by passing through key within brackets right here. So this is going to allow us to grab a specific object, such as idle or run, and then we can grab all the properties within one of these objects as we loop over it. So which property do I want to grab when I'm setting this image.src? Well, obviously we want to grab image.src associated with that object. So back within player.js, right here, as we grab that one individual object in which we're looping over, I'm going to say get the image src and then assign that to image.src within this JavaScript image object right here. And that's going to allow us to start using this within sprite.js. But we're not done just yet. Let's go ahead and set a property of image on whichever object we're currently looping over. So I'll grab that object we're looping over with just this right here, and then say I want to add on top of this an image property equal to the image we just created. And as long as we do this, basically we're adding on dynamically an image property right here set to a new image like so. But by doing things this way, we are using the image source right here associated with each object we're looping over. So this is just a quick way within player.js to make sure that we have a JavaScript image object associated with each animation we want to use within our game. So once we do this, we can start swapping in between those two animations we added in to index.js, idle and run. We just need to determine when do we want to swap between these two. And we can determine when we want to swap between them by when we press certain keys down on our keyboard, whether it be A, D, W, or S, and we're monitoring for that within our animation loop. So if I scroll on down, when we're pressing down our D key, it makes sense to swap on over to our run sprite. So since I want to add in a couple more lines of code right here, I can't use the singular syntax. That just means I need to wrap this within curly brackets. And I'll do that right there with curly brackets. And I know when I press down my D key, I want to swap sprites. But to do that, I need some sort of method. So I'm going to preemptively call player.swap sprite. It can also be switch sprite. Let's just call it that. That's pretty common in regards to what I've called it within other videos. Now, what sprite do I want to switch on over to? Well, our run sprite. Now, this method is not available to us at the moment. That just means we need to code it in to our player class. So let's go back to player.js and search for a good place to add this. So I think right above update is a totally fine place, and I'm going to add in that method of switch sprite. And this is going to take an argument. It's going to take a key argument referencing what key within our animations object do we want to switch on over to. So it can be either, if we look on up here at our keys, it can be either idle or run at the moment. So we're going to pass through that key. Right now we're passing through run, and we want to switch our current image with this .image equal to whichever animation we're selecting from this .animations. And we can get that by grabbing this code right here. I'm going to copy this .animations key and make sure that I'm setting this .image equal to that new animation we're selecting. So we're passing through the key, which is run right here. We pass it through here within this .animations. That's our library. That is setting this .image equal to the run object, the run sprite. But right now, we're really setting it equal to that full image object that has things like our frame rate, has things like our image source. We only want it set equal to that JavaScript image object. As a result, we're going to grab that one image right here and specify we want its image, which we just set up above right here. Now this is totally fine, but I only want to call this once, and that is if this .image is not currently equal to this right here. Otherwise, this is just going to be called over and over and over again, and it's going to be quite inefficient. So right above this, I'm going to say if the current image, this .image, is equal to the current image in which we're trying to select, then we're going to return all together. We're not going to call any of the code down below because we know that this is pointless. We don't want to switch on over to an image in which we're already in that state of. So by running this, we're not pointlessly reassigning this .image to the same image which we're trying to switch on over to. But with this, we should get something working for a running animation. Let's save, refresh, and see what happens when I press down D. You can see now we are within a running sprite. But my hands are off the keyboard, we are not back into our idle sprite like we should be when we're not actually running. So how do we go back to our idle sprite? Well, within index.js, we want to specify what should happen if no keys are being pressed. What happens if D is not pressed? What happens if A is not pressed? Well, we can add in an else statement. I'm actually going to say else if our player.velocity on the y-axis is equal to 0, meaning that we're not moving up and down. I'm doing this for later on when we add in jump and fall animations. So if we're not moving up or down, and we're not pressing D, we're not pressing A, then what do we want to do? We want to call player, and then switch our sprite over to the idle animation, because nothing really is happening. We're not moving or anything. So let's save, refresh, we're within the idle position. Now, when I press D, we run a little bit, and then we go back to our idle position. And you can see over here when I move to the left, I can start running. We're definitely running right there, but once I stop, we go straight back to idle. Now we are running quite quickly and we can't even really see that animation, so we want to make sure that for each animation we have within our new animations library, we have a different frame buffer associated with each, so we can really see what's going on here with our animation. We can fine tune this as needed, but we'll scroll on up to our player class right here where we're defining it, and then within our animations properties, I'll add in a property called frame buffer, similar to the frame buffer we were using within Sprite.js. But I know when I have a run animation, I want to slow this down quite a bit. So I'm going to say our frame buffer is going to be around 7 frames. So for every 7th frame, that is when I want to go on to the next frame within this animation. But since we add a frame buffer right here, we also want to do the same for our idle state. I can't really remember what that was over in Sprite.js. Let's just say that this is going to be equal to 3 for our idle animation. And now we just need to make sure that when we switch over to a sprite, we're also switching the frame buffer. And then eventually we want to switch over the frame rate as well, because not all of our sprites are going to have the same frame rate. So let's make sure we're doing that over in not Sprite.js, but player.js. So when we switch over Sprite, yes, we're switching out the image. What else do we want to switch over? Well, we want to switch over the frame rate and the frame buffer. So let's say that this .frame buffer is going to be equal to the new animation we want to switch on over to, but not .image, rather frame buffer, like so. So that's going to switch over the frame buffer. Can you guess how we're going to do it for the frame rate? Let's copy this line, swap out frame buffer with frame rate. So now we can switch out the frame buffer, the frame rate, and the image, and we should get the effects we're going for when viewing our game. So let's save that, refresh, and now we have this idle animation, but our running animation should be a bit slower, and it's still a little hard to see, mainly because we're moving so fast on the x-axis. So let's slow down our player's velocity on the x dimension. We'll go over to index.js and find where we're moving our player there. Our x velocity is currently equal to 5. I'm going to slow it all the way down to 2 in both directions. Save that and refresh. Now you can see when I'm moving to the right, that is a lot better. We can definitely see that run animation happening as I continue to run. And as I stop, we go back to the idle state. So I think the idle state is perfect. And I might speed up our running animation a bit. So to speed it up, we just need to edit the frame buffer for a run animation. And I'll say the frame buffer is going to be equal to 4 for running. Save and refresh. And that might be a little too fast for me. I'm going to switch that over to 5, refresh. And that seems to be pretty good for the pace we're going. So now we can either add in our run left animation or we can add in jump and fall. I think we'll start with jump and fall and then we'll add everything where we're facing to the left right after that. So how do we add in a jump animation? Well, if we need some sort of new animation to add into our player class, we're just going to go to this animations property and add in one of these new objects. So I'm going to copy run, paste it down below, and instead of reference run, I want to reference jump.png. So jump is going to be the name of this object, and over here for image source, I'm going to reference jump.png. But how many frames is our jump animation? Let's look. Jump.png is 2 frames, so we need to make sure that we're changing that in index.js. So frame rate will be equal to 2. And what should our frame buffer be? I think I want this to go pretty quickly in between these 2 frames. Let's just say that we want this to run for every 3 frames. So jump is now available to us. It's automatically transformed into a JavaScript image object because we wrote that code over in player.js right here with this for loop. Now we can switch to it based on certain conditions. So what is the condition in which we want to swap over to our jump sprite? Well, if we're ever in the air and we're going upwards, I want to switch to that jump sprite no matter if D or A is pressed. So yes, we're going to run all of this code, but immediately after it, if our player dot velocity on the y-axis is less than 0, meaning we're going upwards, I want to immediately select our player, call switch sprite, and then switch over to our jump sprite. So now if we're ever in the air, we're going upwards, we're automatically going to be within this jump state. Let's save that, refresh, jump up. You can definitely see we go into that jump state. It looks pretty cool. Now let's say we want to add in a fall animation too. What is the condition for that? Well, if we're not going up, we're probably going down. So let's add in an else if right here. It says if our player velocity on the y-axis is greater than 0, then in this case, I want to select our player, call switch sprite, and use our fall sprite. But we don't actually have a fall sprite set up above because we never added it in. So let's duplicate jump right here, the jump object, paste it down below, switch out jump in both of these locations with fall instead. You'll see over here, I have fall.png. This is also a 2-frame animation, so we don't need to change this. And I'm going to leave frame buffer at 3 as well. So that'll automatically create everything we need to switch on over to the fall sprite when we are falling down. Let's save this, refresh, and see what that looks like. So right off the bat, we immediately have an issue where we're swapping in between our idle sprite and also our fall sprite. And I know exactly what is happening here. Our order of operations over in player.js for our collision code is very slightly off. So to prevent you from having to debug this and find this yourself, we're going to scroll on down to where we are applying gravity. And in order for our collision detection code and our sprite swapping code to work perfectly, we need to make sure that we're taking this line right here where we're adding on to our y velocity with gravity and place it before we're actually adding on that y velocity to position y. This needs to be in the exact order or else the sprite swapping won't work perfectly. All you need to do is save this, swap those locations, refresh, and now you can see we're not getting that effect where we're continuously swapping between those two. But now you can see if I jump, immediately if the y velocity is greater than 0, meaning we're falling down, we swap back over to that fall sprite. Looks really cool. So as I refresh this, you might notice our player disappears sometimes and sometimes they don't. So this is an obvious issue, and it's happening because right now we're trying to set our image dimensions based off of this idle sprite. That is our default. But immediately, since we're falling down, sometimes it can't load it fast enough right before we swap in to our fall sprite. And as we swap into our fall sprite, we're not loading in the correct dimensions when we call image.onLoad, because that's referencing our old image in which we just swapped down in the first place. So what I want to do here is add in a loaded property into sprite.js to make sure that our image has actually loaded fully before we can swap into anything else. So right above this .image, I'll say that this .loaded is equal to false, but as soon as our image does load, then I'll say this .loaded is equal to true. So we'll save this, and over in player.js, where we have our switch sprite method, I also wanted to say we're going to return if this is true or if this next statement is true. If this .loaded is equal to false as indicated with the bang operator right here, then we're returning, we're not going to swap anything out. It's just going to make sure that our image dimensions are correct before trying to swap into any other sprite sheet. So let's save, refresh, and now no matter how many times we refresh, we're always going to make sure that we get those correct dimensions and we don't get our player disappearing for whatever random reason. So this is looking really good, and if we really want to see how this looks, we can get rid of our hitboxes, or at least just the drawings of our hitboxes, by going to player.js, and inside of our update method, we can comment out the c.fillStyles and c.fillRecs, save and refresh, and that is looking really awesome for our sprite animation. But we do want to add in animations for when we're running to the left, or jumping to the left, or falling to the left. So let's add those in. I actually want you to pause the video, and I challenge you to try adding this in yourself because they're going to be done the exact same way for which we've done these other animations. So give it a go. But otherwise, let's do it together. So in index.js, I want to find where we're adding to our animation library. It's going to be right here on line 64. I want to add in a couple more animations. So I'll duplicate fall and say I want one for fall left. Let's start off with fall left. Now I want to reference not fall.png, but fall left.png instead. You can see we're going to the left here. So we'll add in fall left like so. The frame rate's going to be the same, and the frame buffer is also going to be the same. So now how do we determine when we want to fall to the left rather than to the right? Now it's going to be a little tricky actually if you're doing this on your own, but here's how I would do it. Within player.js, I want to store the last direction in which our player was moving on the x-axis, so either left or right. So I'm going to add in a property to our constructor, and I'll just add this in right beneath this .animations that says this .last direction is equal to right to start, because by default we're going to be facing to the right. I'll save that, and now in index.js I can use that property to determine whether or not we should be falling to the right or to the left. So right here within this else if, I know I wanted to add in a little bit more code, so I'll add some curly brackets, and then within this I can say if our player.direction, or last direction per se, is equal to right, then that is when we're going to call this player.switchSpriteFall, in which we're actually facing to the right. We know there's only one other direction here, which is to the left, so we can just call an else statement that says else, if we're not facing to the right, our player.switchSprite is going to be equal to fall left. But we do need a way in which we're actually changing our last direction. So we know our direction should change based on whether or not we're pressing down A or D, and we're doing that right up here. So as we press down D, we're going to be running to the right, we're going to be facing to the right. So our player.last direction is now equal to right, that is the default. Now I can copy this line, and when we press down our A key, we're going to need some curly brackets right here. We want to call player.last direction left. So whenever we press down our A key, we're facing to the left. Whenever we're pressing down our D key, we're facing to the right. And based off of that, we're either going to call switchSpriteFall, which is to the right, or switchSpriteFall left, which is to the left. So let's see if we did this correctly. Let's save, refresh, we jump, we fall down to the right, but now when I press A and I jump, you can see we're falling to the left. But we definitely need to change our idle direction and our running direction for when we actually go to the left. So let's do that now. Whenever we press down the A key, yes, we're changing our last direction, but we also need to change our sprite to run left. So do we have a run left sprite available to us? Right here. Not at the moment. So we can add one in. I'm going to grab fall left, paste it down below, and change fall out with run. You can see we have that run left animation right here. It has 1, 2, 3, 4, 5, 6, 7, 8 frames. And we want to declare that right here with our frame rate. So instead of 2, we're using 8. We need to make sure we're referencing the fall, or not the fall left, but the run left image. And then our frame buffer is going to be 5 for when we run. So I'll swap 3 out with 5 right here. And now that it's available to us. So we can use it down below, right here, when we're changing our direction to the left, when we're pressing down our A key, by saying we want to grab our player and call the switch sprite method and call run left. So that should get us running to the left. Let's save and refresh. We run to the left, and that works pretty perfectly. So that's all we need to do for running to the left, but of course when we run to the left and stop, we're still facing the right within our idle mode. And that is when we can use this last direction property, but within this else if right here, when determining which idle animation we should call. So if our player velocity on the y-axis is 0, meaning we're just in a standstill, I also want to say if our player dot last direction is equal to right, then yes, we're going to switch our sprite to the default idle animation. Else, I want to grab player dot switch sprite and call idle left instead. So idle left is not currently available to us. We need to go up above and add in that idle left animation. So I'm duplicating run left here, swapping out these properties with idle left instead. And then what is our frame rate for idle currently? It is 8. We have a frame buffer of 3, so 8 is good. We'll swap out 3 right here, save and refresh, and then when we go to the left now and stop, we have that idle left animation. Looks really cool. So I think the only thing left is the jump left animation. Let's add that in while we're up here. I'll grab this object, paste it down below. Reference not idle left, but jump left. I know the frame rate here is 2, and currently our frame buffer for jumping and also falling is also equal to 3. So now that jump left is available to us, we need to determine when to call it. And right here, when we're using player.velocity.y is less than 0, we're switching our sprite to jump right. But we need to determine whether or not we should jump right or left. So within this, I'm going to say if our player.last direction is equal to right. That's when I want to call the default, where we're facing to the right. Else, I'll grab player.switchSprite and call jump left instead. And I think that should take care of everything. So let's save, refresh, and now when I jump, we look good on the right side, I move to the left, move back and forth, and jump when facing to the left. We have that jump left animation. So honestly, it looks really, really cool. And that's all we need to do is start adding in sprite swapping to our player class. And with this, we can head back on over to To-Do and check off sprite swapping. So we are going to move on to platform jumping, but I do want to correct a quick mistake I made within the last lesson. And you'll notice real quick over here within player.js, within our switch sprite method, I am comparing this.image equal to this.animation's key, which is not the actual image associated with the animation we want to reference. So to get that image, all we need to do is add on a .image property right here, and that's going to make sure that this conditional works correctly. If we do not add in .image, then this code down below is just going to continuously run over and over again. We don't want that. So to illustrate what I mean by this, after we add in .image right here, I'm going to console log out the image in which we're switching over to right after we switch to it. So I'm going to call it after all this code, save, open up our console, and then refresh. There's our console, and you'll see this is only being called twice. But if I were to get rid of .image right here, this conditional is incorrect because we're not comparing it to the actual animation image object. Save and refresh. You'll see it's just being called over and over again. It's inefficient. We don't want that. We want to make sure that we include .image right here. And one more thing is, whenever we switch to a new sprite, we want to reset the current frame we're on. So we can do that by saying this .current frame is equal to 0 whenever we switch over a sprite. And the reason we're doing this is, if we look over within our run.png sprite, we might be over here on our 6th frame. And if we're on our 6th frame currently, let's say that we switch on over to another sprite sheet which only has 2 frames. One, such as our jump sprite. So we switch over here, we're on our 6th frame, And if we try rendering out a 6th frame right here when we only have 2 available to us, we're just going to be rendering out blank space. That doesn't make sense, and it's going to cause a quick flash within your sprite. So we want to make sure that we're alleviating that, fixing that, and to do that, we're going to make sure that this.currentFrame is equal to 0 whenever we switch our sprite. So we want to make sure that we add this in and .image right here, and we're going to fix any bugs that you might have had from the last lesson. But just make sure you add that in, and now let's focus on the real issue for this lesson, which is going to be platform jumping. So really, within our game, we have our collision blocks down here, but we want to add collision for our platforms. We're going to start by passing through our platform collisions into our player class. We want to pass these in right here. Right now we currently have our collision blocks going in, but those aren't what we want, because we're going to code these collision blocks differently from the ones we're standing on. We want to be able to pass through these collision blocks and land on top of them. So we need to make sure that they're separate and that we're still passing them through and detecting for a collision, but we're going to be doing this a little bit differently. So let's just start by passing through these platform collision blocks into our player. To do that, I'm going to go over to our player class, player.js, and scroll on up until we hit our constructor. I'm going to duplicate our collision blocks property, and then I'm going to call this platform collision blocks instead. So now I know I'm passing this through within our constructor. I want to assign it equal to a new property, and right here, this is where we're doing our old collision blocks. I'm going to duplicate that, and then reference our platform collision blocks. Just set it equal to that this.platform collision blocks property, and we're pretty much good to go. Now all we need to do is pass through those collision blocks into this player class for the constructor we just created. So over in index.js, let's find out where we're adding in collision blocks to our player. And it's going to be right here on line 61 for me. Now I know I have a new property available to us. It's going to be platform collision blocks. And this is going to be equal to, I believe, platform collision blocks. Let's double check this. Let's make sure that we can find this const or variable right here. I'm going to scroll on up, and yep, that is exactly what it's called. Platform collision blocks contains all the blocks related to our platform objects. So we're passing that through into our player, and since these have the same name, we can use the shorthand syntax, which I mentioned earlier, save, and now these are completely available to us over in player.js. So now that we have these within our class, we can begin detecting for a collision between our player and these new blocks. How do we detect for collision? Well, I only want to detect for collision when our player is moving up or down. And currently, we're doing that by using this method we created earlier, check for vertical collisions. So this checks for vertical collisions between our player and our collision blocks, the ones we already added in our game. But now we need to detect for the platform collision blocks we just passed into our player. So to do that, I'm simply going to copy this for loop all the way down to the very bottom right here, and then paste in a new instance of it. And I'm going to add a comment right above it that this says, this is for our platform collision blocks. Now what I need to do is replace every instance of collision block with platform collision block, the one that we're passing through to monitor for our platform collisions. So using Sublime Text, I'm going to use this cool little shortcut where I select what I want to change. It's just going to be collision block, and then I'm going to press Command D multiple times to select every instance of collision block until I hit the very last one right here. Once I hit the very last one, I can hit backspace, that deletes it, and now I can reference platform collision block instead. So now you can see I'm referencing within our for loop the platform collision blocks.length. We're going to loop through every platform collision block. We're going to store the one platform collision block we're looping over inside of this variable right here. And then we're going to detect for a collision between our hitbox and that one platform collision block. And right now, these statements determine where our player should be placed once we hit one of those platform collision blocks. So if we save this as is, making sure that we updated everything with platform collision block, and then refresh, we should have collision detection very similar to how our collision detection works with our other collision blocks that are already in the game. So let's test this out. We're going to hit one of these platform collision blocks by jumping up, and you can see we kind of just bounce right off of it. That's perfect. If I hop on top of this, you'll see now we're standing on top of it. And if I press up underneath this one, you'll see we bounce off the top of that one as well. That's perfect. That's exactly what we want to start. But we want to be able to pass through these on the bottom side. So as I move over to the left and jump, I want to be able to pass through these blocks right here. So over here in XD, I made a small illustration to show you how this is going to work. So this blue block right here is going to represent our collision block, and obviously this right here is our player, just different colors to help illustrate what's going on. Right now, when we hit the bottom, we are bouncing off the bottom of the block and we fall back down. We're going to remove that code that places us at the bottom of the collision block. So where is that code being called? Basically, when our y velocity is negative, meaning we're going up, we're going to remove that code altogether within our collision function right here. So we know when our velocity is negative, as stated right here on line 176, that we're going to place our player at the bottom of the collision block. We no longer need this code. We're going to delete it completely. Save, refresh, and now when we try jumping through one of these platform collisions, we go through it and we stand on the top. Now this might seem like it works, but it doesn't work correctly, because if I hit this block right here, you can see we're at the very bottom and then we're just transported to the top. So what is happening right now? Well, back over here within our illustration, we have our player, and when we jump up, we're going through our collision block. And eventually we're going to be in a spot like this. Now our y velocity, we're currently moving up, is negative, but eventually it's going to be a positive value, meaning we're moving back down because we have gravity always pulling down on us. And once that hits a positive value, you can see we're still colliding with our collision block, but our y velocity is now positive. And if we have a collision and our y velocity is positive, what's happening? We are calling this code right here, which places our player on top of our collision block. So that's exactly what's going on right now. We need to make sure that we fix this. And there are a couple ways to do it, but this is probably the easiest. The first thing I'm going to do is shrink our collision block right here to make sure that it's only taking up the height of the platform. This is going to reduce the area in which this effect can occur. So let's start by doing that. So to reduce the height of our collision block, specifically for our platforms only, I want to go inside of our collision block class. And I'm going to make this height property dynamic by assigning equal to a height we pass through our constructor. So I know by default I want all of our collision blocks to be a height of 16. So I'll add that here, saying our default height is 16. But for our platform collision blocks, I want to change this. So I'm going to do that over in index.js when I create each platform collision block. It's going to be right here on line 42 for me. And next to this property of position, I want to add in another property called height. This height is going to be a lot smaller than 16. Let's just say it's equal to something like 4 and see how that looks. So I save, refresh, and that's already looking a lot better. But you'll notice when I play our game, if I press W twice to jump twice, you'll see we still collide with the platform and we're placed on top of it. Still not what we want, even though it's harder to obtain that effect of just being transported to the top. So what is happening now? Well, basically the same thing as before. We're still changing our y velocity to be a value greater than 0 as we fall down. And as a result, even with this shrunk height for our platform collision, we are moving our player back up here as soon as that velocity turns greater than 0. So what we want to do is make sure that we're not monitoring for collision between any point of our player besides the very bottom of it. We no longer want to monitor for collision when we hit an area like this. We only want to, say, place our player on top of this collision block if the bottom of our player right here is inside of the platform. So this is valid until it goes past the height of the platform collision. This is not a valid collision right here. So we need to write a new collision statement to take this into account. We're going to do that inside of utils.js. So this is our standard collision right here. I'm going to duplicate this by copying it, pasting it down below, and I'm going to call this new one platform collision. And yes, we're going to monitor between object 1 and object 2. Object 1 will just be our player. But right here on line 13, we're saying is the top of our player, as indicated by object 1 position y, less than the bottom of our collision block. So that's basically monitoring for anywhere from the top of our player to the bottom of the player. We only want to monitor for the bottom. So we're going to say right here, we want the bottom of our player by adding on to our object 1 position y, our object 1 height. So what we're saying now is the bottom of our player greater than the top of our collision block, and is the bottom of our player less than the bottom of our collision block. Is the bottom inside of the height of our collision block? That's what we're saying with this new platform collision function, and that's exactly what we want. So let's save this, and then make sure that we copy our function of platform collision, and then go over to player.js, and we're no longer going to use our standard collision for our platform collision blocks, but rather our platform collision. So with this, we can save, refresh. Now you can see when I jump and we collide with this platform right here, we're no longer going to be transported to the top of it unless the bottom of our player is colliding with this area right here. So let me try to get that. And you can see that works almost exactly as needed. There is a small buffer as we have 4 pixels in which we can land on and be transported to the top, but I think that's totally okay for how our game is supposed to function. Now we're not done just yet. I want to show you this. If I jump on top of this and I jump up a lot of times right above that, we're going to fall back down immediately, and you'll see that I passed through the platform collision. What is going on there? Well, back in XD, eventually we're going to go really high up past our platform, right? So let's just say we're up here and we're moving really fast downwards. Our velocity is going to keep increasing, and we might be at a point where we're right here. But let's say our velocity on the y-axis is really big, meaning that our next frame in the animation cycle is going to be pushing us below our platform collision. So the bottom of our player is no longer colliding with our platform because we're moving so freaking fast. And as a result, we just keep going down past the platform until we hit the very bottom of our game down here. So in order to fix this, the best way to do it is to slow down our game, specifically on the y-axis. What we're going to do is make sure that we're only moving down at a slow rate in which we can always collide with one of these platforms. And to do that, we're going to be editing our gravity values and also our y velocity whenever we jump. And as long as we slow things down by quite a bit, we're going to make sure that we always get this collision in place. That's always the easiest way to do it when monitoring for a collision where we might pass through an object. So let's go ahead and add that in. Over in index.js, we want to find our gravity variable. For me, it is on line 55. All I need to do here is edit this to something lower. Let's edit it to something like 0.2 and see how that looks. I'm going to save, refresh, jump, and you can see we're going up really, really high, but if I try jumping above this platform collision block right here, we are still falling through it. So we can either edit our gravity value some more, or edit how high we are jumping. Let's start with editing how high we're jumping, and that is going to be at the bottom of our page. We're selecting our player velocity on the y-axis and setting it equal to -8. I'm going to set it equal to something like 4, save and refresh, and now you can see we're not jumping as high. If I double jump, yes, we're landing on top of this, but we're still going to get the same effect where we jump up really, really high. We're going to fall down and go through this platform right there. So I want to slow things down even further on our gravity side. So let's find gravity once more right here. And I'm going to change it to something like 0.1 instead. Save and refresh. And now I kind of like how that looks. It makes our game a lot easier to play as well. And I think as long as we keep things as is with this slow gravity, even when we start panning things around and we jump off a really high platform and hit a low one, we shouldn't be able to go through it. And if we ever do, we can lower this gravity value or lower our player velocity on the y-axis when we jump. And by using a good combination of the two, we should prevent our player from ever falling down past one of these platforms. We can always test it by double jumping right here above this platform, and we're not going through it. That is a good start. It's a little hard to test right now because we can't actually pan our camera, but we'll test it a bit more when we start adding in that camera movement. So I think this is a good state to prevent us from falling through these platforms and allowing us to jump on top of them while maintaining a good jump height. So with this, let's head back on over to To-Do and check off platform jumping. Next, we're going to add in horizontal camera panning. So as our player moves over to the right, we want to make sure that we're scrolling our scene so we can reveal more of the area in which we want to play in. Eventually, we're going to do the same thing for when we jump up and down, but for now, we're going to focus on the x-axis. So how is this going to work? Well, over in XD, I mocked this up real quick. You can kind of see what's going on here. So right now, our red box is our player, and these two lines right here are our canvas width, or at least that's what they represent. So what I want to do is add in this blue box around our player, which represents our camera. This is going to be our camera box, which we're going to use for collision detection between the right and left-hand sides of our screen. So if the right side of our camera box collides with our camera canvas, if this value is greater than or equal to this value right here of 256 pixels, then we're going to translate our entire scene over to the left. And as we translate over our entire scene, it's going to give off the illusion of movement as we continue moving over to the right. So we'll cover this a bit more, but first thing first, let's add in this blue camera box around our player. We're going to go to player.js and then assign a property within our constructor. So I'm in my constructor right here on line 39. I'm going to add a property called this.cameraBox is equal to an object with a position that has an x. I'm going to set that equal to 0 to start, a y equal to 0, and then we're also going to have a width, which I'll set equal to 200, and then a height, which I'll set equal to 80. So thinking about this, I want our position to always be based on the x and y position of where our player is spawned and moving. So really, I guess 0 for position x and y doesn't work. We'll set this equal to this.position.x. and then our y equal to this dot position dot y, so that it always follows our player, or at least you would think. So I want to draw out this camera box next, and to do that, I'm going to find where we're calling update. So update right here is on line 58 for me, and I know we have some code which draws out some boxes for our hitbox and also our image box. I'm just going to copy our one for hitbox, and then paste this before the others, uncomment it out, change the color from red over to blue by changing this third argument to 255, and then I want this to take up not our hitbox area, but rather our camera box area instead. So let's save this, refresh, and you're going to notice while our camera box seems to be the correct height and width, but it is not following our player around. So we're setting it equal to our player position when we first create our player, because this is called within our constructor, but we're not updating this for every frame. We need to make sure that we're doing that. So right here, I'm going to copy this code we just wrote for our camera box, and I'm going to add in a new method called update camera box. And when we call this, I want to call the exact same thing we called earlier. So now I just need to make sure that I'm calling update camera box within our update method. So right before I actually call our draw code, I'll call this dot update camera box, save, refresh, and now that follows our player around. So we're off to a good start, but I want our player centered in the middle here. And to do that, when we update our camera box, I just need to offset our X position by a little bit. So whenever we set our X position, I'm going to subtract a value of, let's just say 50 pixels from it, save and refresh, and I think that might be just perfect. Our camera box is now off to the left, and our player is placed perfectly in the center. This is exactly what I want to start. So looking at XD over here, we basically just created this blue rectangle, which now we can use to detect for collision between the right and left-hand sides of our screen. So that's going to be the very next thing. We want to say, is the right side of our camera box greater than or equal to our canvas width over here? So let's start by getting the right side of our camera box and running that whenever we press down an input of D, which moves us over to the right. So I'm going to add in another method, and this method is going to be should pan camera to the left, because when the right side of our camera box is colliding with the right side of the canvas, we should be moving our camera to the left, translating our whole scene leftwards. So within this method, what I want to do, I want to check for the right side of our camera box. Let's get that. I'm going to create a const called camera box right side. This will be equal to the camera boxes, so this dot camera box dot position dot x plus this dot camera box width. That's going to give us the right side of the camera box. We're off to a great start. But now we want to use this within a conditional that says if the camera box right side is greater than or equal to the right side of our canvas, which we can get with canvas.width, then we want to begin translating things. So in here I'll say translate to the left, because we want to move our whole scene over to the left when we're moving towards the right. But something to note here is canvas.width is equal to 1024, but we're in a completely scaled version of our canvas because we scaled everything up by 4 times. As a result, I want to divide this by 4 to make sure we're getting accurate values. If I go back to XD over here, we want to make sure that this value over here is greater than 256 pixels. If I multiply 256 times 4, what do we get? We get a value of 1024, which is the full size of our canvas originally before we scaled anything. So right here, we want to make sure that the right side is greater than our canvas width divided by 4, which is 256 pixels. And that's exactly what we're checking for right here. If we need to understand what canvas width divided by 4 is, we can always create a const called scaled down canvas width. Set that equal to canvas width divided by 4, and this is a little more understandable, at least I think so. So now that we have this method available to us, we can check when we should be panning our camera over to the left. Where do we do that? Well, I'm going to do it within index.js whenever we are actually moving to the right, and that's going to be when our D key is pressed and our last direction is equal to the right. So right here, I'm going to say if our player dot should pan camera to the right. I believe that is the method. If I forget, I can go to player.js. It looks like I did get it wrong, so I'm just going to copy this method, replace this, should pan camera to the left. Player should pan the camera to the left. We're going to pan the camera to the left. Let's save this and see if we're console.logging out that text. So now when this collides with the right side of our canvas, or if it's greater than that, see I hit down D, we're going to console.log out that text. But it's only going to occur when this right side is actually greater than the width of our scaled down canvas. You see nothing's being logged out here, but as I move past the right side, we're logging that out no matter how far that I go. So once this occurs, we want to begin translating our canvas. How do we do that? Well, over in our code, you'll notice we have the c.translate method, and x is always equal to 0 currently. We're going to make this equal to a dynamic value, which we change based on that condition of whether or not the right side of our camera box is greater than the canvas width. So right above our animate function, I'm going to create a const called camera. This is going to be equal to an object with a position that has an x equal to 0 and a y equal to 0, because that's where it's going to be to start, well, at least on the x-axis. So instead of referencing 0 right here within c.translate, now I can reference this value, which we're going to make dynamic, by grabbing camera.position.x, and now we want to change this based on whether or not we should pan the camera to the left. So we know we should do that within player.js. We know we should pan it whenever we're console out this text. So how do we pan our camera to the left? Well, we're going to grab our camera object, which we just created, get its position on the x-axis, and from this we're going to subtract from its current value our player's velocity on the x-axis. So this dot velocity dot x. So for however fast we're moving to the right, we're going to translate our canvas at that same speed, and that's going to give us an accurate translation movement to look as if we're really moving through our scene. Now, if we want to be extra explicit with our code, it might be a little confusing to us in regards to where camera is coming from and where canvas is coming from. These right now are global objects which we're pulling in, but I kind of want to be extra clear here to know that these are being passed through our method. So to pass these through as a method argument, I'm going to add in an object here and declare I'm passing through a canvas and also a camera. Now I know that camera and canvas are coming through here as arguments. So save player.js, and now we just need to make sure we're actually passing them through our method down here. So I'll add in that object, add in the canvas that we declared all the way at the top of our file, and then also add in the camera that we declared up above our animation function. So we're just being extra explicit with our code. It makes it easier to understand where these variables are coming from, but let's save. When we collide with the right side of our canvas, we should translate stuff. So let's hold down D, we move, and our scene is translating. Perfect. That's exactly what we want to start. So as I begin moving over, and I move back to the left, you'll notice we're no longer touching the right side of our canvas over here, but if I hold down D again, we're still translating things. And that is incorrect. We only want to translate stuff as long as this right side of our camera box is greater than or equal to the right side of our screen. So what is going on here? Well, I can show you over in XD. So whenever our player's camera box passes this point right here, we're translating our canvas by the same amount. So let's say our canvas is actually right here to start. We just translate it over by the same width as this area right here. You can see this is pretty similar to the width that we translated by on the left-hand side. And that's perfect, that's what we want. But let's say that we move back by just a little bit. If I start moving to the right, we're still going to be translating stuff because we're still past this point. What we want to do is whenever we move to the right and we gain distance past this value, we want to add on to this distance whatever we translate it by. So however long this translation is right here based off this box, however long this box is, we want to add it on to 256, the width of our canvas. And as we add that on, we're basically going to be increasing this value in which we need to test for whether or not there is collision between the right side of our camera box and this new value. So this value is going to be continually increasing, and we're going to continually monitor for whether or not the right side of our camera box is greater than that value. So basically we're just moving the goalpost in which we want to activate our collision detection code. So if we're at this point right now, we're going to move over our goalpost by this exact width right here, and now we can only call that code if we continue passing this new value which we're updating. We're just continually updating the goalpost for every frame we move past it. But you'll see if I move our player back to the left and I start moving to the right, we're not going to activate any translation code because we're not past this new goalpost value. We only want to move this back to its original position if our player on the left-hand side collides with this left goalpost over here, which translates things back in the opposite direction. So whenever we collide with our first goalpost, we start moving past it, we want to add on the translation value as indicated by this little square right here. So really we'd only be translating by this amount. We want to add on the width of this small white square right here to our goalpost value. How do we do that? Well, we're going to do that within player.js. We're going to say if the right side of our camera box is greater than our scaled canvas width plus that camera offset, which is actually the width of this white box, then that is when we want to translate our camera. So how do we get our camera offset? We can reference the camera we're passing through, and then select its position on the x-axis. Now this is going to be a negative value to start, because when we translate our camera over to the left, the further to the left we go, the less the x value gets. That's just the way the coordinate system works. So this right now is negative, but we want to make sure that this is positive. And we can do that by wrapping this in a math.abs function, stands for math absolute. So we're going to make sure that camera position x is always a positive value. So now if the right side of our camera box is greater than our canvas width, plus the amount we translated by, which is going to be the white box right here and here, then we know that we should be moving over our camera to the left further. So let's save it and test it out. Refresh. We move over to the right, everything's working as expected. But you'll see when I go back to the left and move to the right, we're no longer just panning to the right aimlessly. Only when the camera box is past this area over here can we continue pushing onwards. That is exactly what we want to start. But eventually, you're going to notice we just keep panning our scene till we get this white box over here. We want to prevent that from happening altogether. So what I want to say is, if our camera box's right side is greater than our image width, I don't want to pan anything at all. I'm going to write that out within the should pan camera to the left method. So before we actually pan our camera with this if statement down here, I want to add in a new if statement that says if the right side of our camera box, we can get that with this variable right here, is greater than or equal to the width of our image, which the width of our image for our background right here is 576 pixels. So I'm going to add that in. If this is greater than 576, I want to return all together. I don't want to call any camera panning code. Let's save this and see how it looks. Refresh, we move to the right, it looks good. Move to the left, no issue there with the panning. But if I go all the way to the right, we're going to stop panning altogether because we added in this new conditional, which prevents our camera from going off the screen and showing up that white area. So that takes care of panning the camera to the left, but now we want to take care of functionality when we need to pan the camera over to the right. So what I'm going to do is I'm going to duplicate this function, paste it down below, and now I'm going to say, should we pan the camera, not to the left, but rather to the right? And I'm just going to delete all the code inside of here to start. Now when should we pan our camera to the right? Well, not when the left side of our camera box is less than or equal to the starting position of our camera, which is 0 right here. If the left side of our blue box is less than or equal to this red line, we do not want to do anything ever, because else if we try panning this to the right, we're going to see a white box right here. We do not want that within our game. So we're actually going to start by preventing us from going to the left by adding in a conditional that says if the left side of our camera box, which we can get with this .cameraBox.position.x, is ever less than or equal to a value of 0, we're going to return we don't want to pan anything at all. But now beneath this, we can determine when we do want to pan. So when should we be panning within our scene? Well, eventually we're going to be moving on over to the right, and we're going to pan our scene by the amount over here. So let's just say we pan it by that exact amount. Now we have a scenario in which we can pan our scene back to the right. And that scenario is the left side of our camera box less than this new goalpost right here. The original goalpost is going to be over here for our starting, but since we panned everything, we have a new goalpost in which we can test for a collision with. And that goalpost location is indicated by our camera's translation once more. So we want to test, is the left side of our camera box less than or equal to the amount in which we translated our entire scene by? So let's do that. We'll say if this .cameraBox.position.x is less than or equal to our camera position.x. And remember, this is a negative value, so we want to make it positive. We can do that with math.abs. And make sure that we add a ending parentheses right here. If this is true, we want to translate our camera going in the opposite direction. So I'm going to grab this line of code right here, in which we're translating our camera, paste it within this if statement, and this is actually totally valid, because this .velocity.x is actually going to be equal to a negative value, because we're moving to the left. This means that this is negative. And if we ever subtract a negative value, that just means we're pushing the camera over in the opposite direction. We're going to be moving the camera to the right. So we don't actually need to change this code right here. It's going to be the exact same as we used it up above, but this should be good to begin panning things over to the right. Now we just need to call, should we pan the camera to the right, over within index.js when we're pressing down on our A key, which moves us to the left. So right after everything within there, I'm going to call player, should pan camera to the right, and I need to make sure that I'm passing through our canvas. Also our camera, so we can reference those correctly within the method. But let's save, refresh. You'll see when I go over to the left, not panning anything, which is correct. But if we move to the right, move our camera over a little bit, and then I go back to the left, now we're panning everything back to the right. That is perfect. Exactly what we want for that functionality to work. Now we're almost done with panning, but you'll see if I go off towards the right side of the screen, I can keep on going until I fall off, and we have no more collision blocks to hold us in place. So we want to make sure if our hitbox collides with the right side of the screen, we prevent our player from moving altogether. And to do that, I'm going to go back inside of player.js and write one more method. This method is going to be called check for horizontal canvas collision. And here's what we're going to do inside of here. I'm going to say if our player's hitbox on the right side, which I can get with this .hitbox.position.x plus this .hitbox.width is greater than or equal to the full width of our image, which remember is going to be 576, then I want to take our player's velocity, so this .velocity, on the x-axis and set it equal to 0. And actually, I almost forgot, I want to add on our player's velocity here as well, so we don't actually get stuck on the right-hand side of the screen when we collide with it. Because if we get stuck, we're not going to be able to move back. So we want to make sure that we're checking one frame in advance to make sure we're not colliding with the right side. But if we are, we're going to set our x velocity equal to 0, meaning we cannot move past that point over there. So we want to check for horizontal canvas collision at some point, and that point is going to be right before we call player.update. Because I don't actually want our player to update or move at all based off of this new conditional I just wrote. So here I'm going to call player.check for horizontal canvas collision. We could also just add this inside of our update function if we really wanted to, but let's see how this looks. I'll save that, refresh, and now we should not be able to go off the right-hand side of the screen. Let's double check it. And yeah, you can see as I try to move past that point, it just won't let me. If I stop, we go back to our idle state, and I can freely move around back to the left direction. But we're going to want to do the same thing for when we go towards the left side of the canvas, which has an x position of 0. See, I can move past it, and I can just fall off the side of the screen. So back within player.js, where we're checking for horizontal canvas collision, I'm going to add in an OR statement, and then I want to check for whether or not the left side of our hitbox, which I can get with this .hitbox.position.x, is less than or equal to 0. And I always want to make sure that I'm adding on our y velocity here so we don't get stuck with that left side of the screen. So I'll add on this .velocity.x. This basically just checks one frame in advance whether or not we're colliding with that left side. And if we are, we're going to set our x velocity equal to 0. We're not going to get stuck over there, but we're not going to be able to pass that point either. So we save that, refresh, and we go towards the left side of the screen. You can see I just can't go past that point anymore. Our collision box might be a little off, but we can always edit that as needed, but I think this is totally fine for preventing us from going off that side of the screen. So that's really all there is to it for adding in a camera box and panning our camera left and to the right. The next thing we want to do is add in panning for when we go up or down. But for now, this is going to allow us to check off horizontal camera panning. So now we're going to work on vertical camera panning, and the nice thing is it's going to be very similar to how we did the horizontal camera panning. We're just going to be using the y-axis. So how do we start with this? We want to go inside of player.js and find where we should pan the camera to the right. So I'm going to duplicate this method, paste it down below, and I'm going to rename this should we pan the camera down. So what that means is when the top of our camera box reaches the top of our viewable area, we want to translate our entire image downwards so that we can see more of the scene above us. So we're going to be panning the camera down. Now I'm going to comment out this first if statement, and we can focus on actually changing our camera position, but on the y-axis. So anywhere that we see a position.x or a velocity.x, we want to change that to position y in every single location right here. And we're already off to a great start with this. So camerabox.position.y is the top of our camera box, while camera.position.y over here is going to be how much has our actual viewable camera translated by. So what this if statement means right now is if the top of our camera box right here is less than or equal to the amount we've translated by from the very top of our actual image, which is going to be the full height of this white box right here, then I know that I want to translate our entire scene downwards by our player velocity. That's going to make sure that our player is right here. We shrink this over here by a little bit, and we're just going to keep activating this code that uses our camera's translation over here and the top of our camera box. So when we look at this if statement, this is the top of our camera box, while this is the height of that white box as indicated by camera position.y. And once we pass that point, we're going to continuously add on to camera.position.y because we're subtracting a negative value, because this dot velocity is going to be negative because we're moving upwards. But this code isn't going to work right off the bat, even if we call should pan camera down. We're going to call this code, so let's copy it, go into index.js, and find out where we should be calling it. It's going to be when we're calling player.switchSpriteJump, when our player velocity y is less than 0, that means we're going up. I also want to call player.shouldPanCameraDown, and this takes an object with a camera and also a canvas. So now we're going to be checking for that, but right now our camera on the y-axis right here is not dynamic. You'll see when we're calling c.translate, we're using this code right here, which translates our image to the correct position to start, but this needs to be dynamic. We need to change this value over time based on when we check for whether or not we should pan the camera down. So for our camera's position on the y-axis, I actually wanted to take this code right here, cut it out of its current position, and replace 0 with that, because by default, we're translating our camera to make sure that we start off at the very bottom of our entire scene, which uses background image height and our scaled canvas height. We did that when we were adding in our background image originally, but one thing I want to note is when we set this is going to be called immediately when we load index.js, and if we call this immediately, background.image.height is not going to be available to us because an image takes some time to load, and this is definitely going to call before this has loaded. So we want to use a static value right here of what our background image height is. And I already know off the top of my head that this height is going to be 432. You can just go ahead and check the height of the image you're using for your game and add that in right here. But this 432 is our background image height. And if we want to be extra explicit with our code, we should call this a variable called background image height, and assign this equal to the value of 432. So now we know exactly what 432 is right here within our code. It's a lot more understandable, but we don't need to wait for our image to load. It's just going to use this static value instead. So with our camera position y now available to us, we can translate our scene by that exact amount on the y-axis by referencing camera position.y. Everything should still function exactly the same as before. We refresh, and yes, the camera position is still at the very bottom of our image. We're not starting at the top. That's perfect. But now watch what happens when I jump. You're going to see when the top of our camera box reaches the top of our actual viewable area right here, the top of the camera's offset on the y-axis, we are panning our entire scene up by moving that camera y position. We can just keep on jumping until we reach the very top, and now there's nothing up here. Kind of doesn't make sense to keep on going. So that brings us back to player.js, where I commented out this if statement. We kind of want to do the same thing, but on the y-axis that says if our camera box's position on the y is less than or equal to 0, which is going to be right here, then we don't want to call anything that actually pans our camera on the y-axis. We're just going to return, we're not going to call this code. So let's save that, refresh, and test this out. So we'll keep jumping towards the top of our scene. You'll see once I get up there, we can't go past and reveal that white area which we were showing before. But there might be an issue in the future where we've panned our background by a little too much because we didn't take into account our player's velocity when moving up or down. These values can be pretty great based on how fast our jump velocity is and how high our gravity value is. So here I wanted to say I don't want to call any panning code if the top of our box plus our player's velocity, which I can get with this .velocity.y, is less than or equal to 0, is just going to check one frame in advance to make sure that we don't actually pan things by an amount which is too great, which might actually show that little white bar which we've been dealing with sometimes within our game. So let's try this one more time with that velocity in place. We jump towards the top of our scene, and yeah, I don't think we're going to be seeing any white bar anytime soon because we're checking that one frame in advance. But now we do want to add in panning for when the bottom of our camera box right here touches the bottom of our viewable area. So I'm going to duplicate this method we just created. Should we pan our camera down? Paste it down below, replace down with up. Should we be panning our camera up? When should we decide this? I'm going to comment out this first statement and just deal with the actual panning to start. So let's say we're currently in this location. When should we start panning our scene upwards till we hit the bottom of our ground? Well, when the bottom of our camera box is greater than or equal to the offset in which our camera has panned on the y-axis, starting from the top, plus the height of the viewable area, so our canvas height divided by 4. Let's add that into our code. So we're going to say if our camera box position on the y-axis, and we want the bottom of that camera box, so we're going to add onto this .cameraBox.height is greater than or equal to our camera position y, math absolute, so that's always a positive value, but we want the bottom of the camera box, so we need to add on to this our canvas.height divided by 4 because we're within a scaled version, and we want to be explicit in regards to what this is, so we'll say const scaled canvas height is equal to canvas height divided by 4, and then we can replace this in this location with scaled canvas height. And that's all there is to it. As we start moving down, our camera should be panning up. We just need to make sure that we're calling this function as we're actually falling. So I'm going to copy this. Should we pan our camera up? Go to index.js, find out where we're falling. It's going to be right here within this else if statement where player velocity y is greater than 0. I'm going to call player should pan a camera up. This takes an object with a camera and also a canvas. Now we know whether or not we should be panning up or down. Save and refresh. And let's start jumping up a bit. And then we're going to fall from the first platform, and we pan our camera down. Perfect. But there might be an instance in which we don't want to pan down any further, and that is when the bottom of our camera right here is past the bottom of our full image height. So we want to go back to player.js and make sure that we reactivate this if statement that gets the bottom of our camera box. So we need to add on to our camera box position y, this .camera box height. We'll add on the y velocity to do a one frame check in advance. So if the bottom of our camera box is greater than or equal to the image height, which I know is going to be 432, we want to return all together. We should not be panning upwards at all to reveal area that doesn't exist. Refresh, everything should still work as expected. Let's test it out. We fall down, we look good, we jump around a few times. And yeah, I really like how this is looking. I don't think we need to do much else for panning on the y-axis. So I think the last thing I want to do is basically just comment out all this collision code that we have in place to draw out our collision blocks, our platform collision blocks, and also our camera box right here. I just want to see how our game looks without all this dev stuff in there. So let's start off with our camera box. Over in player.js, I want to go inside of our update method and then comment out the code which draws out our camera box. So lines 130 down to 136. I'll comment those out. Save and refresh, that is gone, but our panning is still going to work as expected. Now let's comment out our collision blocks. I can do this over in index.js, and that's going to be within our animate function. So I'm looping through our collision blocks, and I'm looping through our platform collision blocks. I want to comment out these lines of code so that we're not drawing them out. That's all that's happening when we call update. We're still using their dimensions within other functions, but right here it's just unrequired for us to render things. So I comment those out. Those are gone, and with that you can see we have a very beautiful map. No collision blocks, platform collision blocks being rendered. And we can jump around our whole map as needed. Because we added in all that camera panning movement, we successfully created a vertical platformer that also pans to the left and to the right. So this is going to allow us to go back to to-do and check off vertical camera panning. So we basically finished the coding for our game, but now we want to make it live on the web. And by now, your hosting or domain should be completely live and ready, and showing your game that you uploaded previously, whether it be the canvas which we uploaded together, or your current saved instance in which you uploaded on your own. But since our game is complete, we're going to upload the finished version together. Let's do it now. So I'm back on my hosting or dashboard. You can see right here, we still have my premium shared hosting, still have my domain name. I want to go over to my premium shared hosting, click manage, and then if I click Chris Courses XYZ now, it's going to open up in a new tab, and you can see that our domain has successfully transferred over. We can view our game, which I personally uploaded in the very beginning with just this canvas. This is all the way at the start of project setup. So we're about to make a big change right here. To update this with our new game code, we'll go to dashboard, and then I want to go back to our file manager. So that's going to open up a new tab over here. I'm just going to let that load for a little bit. And now we're immediately presented with public.html. So whatever files are inside of here are going to be rendered out over at chriscourses.xyz. So I'm going to click this, double click into it, and I want to replace the contents of this with vertical platformer. So I'm going to go inside of my project, which is vertical-platformer, and then grab all the files inside of it, everything from JS to image. And I'm selecting that by grabbing this first folder, holding down shift, and then clicking the image folder up here. I just want to drag this on top of our interface over here, let it go, and yes, I do want to replace any files here currently because I know those are out of date. I'll hit replace. And now all of our files are uploaded really quick. I can refresh at Chris Courses XYZ. And you might need to do a hard refresh, which with Chrome I can do a Command-Shift-R just to clear the cache. And now our game is live on the web at chriscourses.xyz. Really cool stuff right there from Hostinger. It makes it super simple to upload your game. And now all of our code works exactly as expected. So if you wanted to send this over to a friend to show all of your progress, this is how you would do it. Thank you, Hostinger, for making this possible at a very affordable price. But now that we have this game at a live URL and everything is completely coded, let's go ahead and admire the results. Now, getting our platformer set up with a camera is only step 1 of the process. If you're interested in learning how to make your player attack, then check out this tutorial right here, where I'll teach you how to activate and respond to attacks within your very own fighting game.